Right, we've got our avatar back. Great. Hey everybody, it's me, the Shy Hat. It's gonna be boring if you're just muted all stream. Yeah, that's true, that's true. Alright, so let's talk about what we're gonna be doing today. We're doing HackerFrogs AfterSchool, we're doing HackerFrogs free hacking, we're hacking all the things. So let's talk about the topics we're going to be covering on today's live stream. So it is, we do 2 live streams a week, one on Wednesday and one on Friday. If you ever want to see the schedule for these live streams, you can find it over at the Reddit over here. And today is Friday, May 22nd, 2026. TGIF, everybody. And today we're going to be doing our first topic. Our first topic is going to be research. We're going to be learning about AI basics with elements of AI. This is an online learning course, and we've been working our way through it because we want to learn more about AI because people won't stop talking about it. So that's going to be the first topic of today's stream. For the second topic, we're going to be doing some challenges over at the OLIcyber website. OLIcyber is an Italian cybersecurity education platform, and we're going to be learning about some PCAP forensics over there. That's going to be the second hour of today's stream. In the third hour, we're going to be doing HackerFrogs AfterSchool. That 60-year-old technology. We're talking about AI? Yeah. I mean, the stuff that's being used now, it was started up in the 60s. Let's see where it is today. So the third topic we're going to be doing today is HackerFrogs AfterSchool. We're going to be doing digital forensics, and we're going to be learning about how to do disk image forensics with the program called Autopsy. So Autopsy is a pretty popular choice for doing disk image forensics. We're going to be learning about that with the TryHackMe platform. The last topic we're going to be doing today is a challenge. We're going to be doing TryHackMe Intro to AD Breaching. So AD breaching, we're talking about Active Directory in Windows, and we're just going to be reacquainting ourselves with Active Directory and hacking Windows. That's going to be the last thing that we're going to be doing today, and the fourth and fifth hour, maybe fourth, fifth, and sixth hours of today's stream. All right, so without further ado, let's get into our warm-up topic. That's going to be our education topic, and we're going to be learning about AI. So we'll put 60 minutes on the clock, and we will get started. All right, so let's get going. So last time they wanted us to do the perception of AI, and they wanted us to... Didn't we answer these already? I'm pretty sure we did. Am I not logged in? No, I am logged in. Let me reload the page. So if you ever want to see exactly what we're studying over at HackerFrogs, this is it over here. And I notice we don't have any music on right now. Let's go ahead and put a little bit of music on while we do our stream. If you ever find that the music is a little bit too loud, let me know. Well, that's a bit too loud right now. And I'll adjust the volume accordingly. Okay. All right, so about predicting the future, didn't we already do this? Oh, we were talking about Terminator Doomsday scenarios last time. That was a lot of fun. Anyways, let's read about some of the other answers that some other people gave over here. So exercise 23, what is the perception of AI? For this exercise, we want you to think about how AI is portrayed, do an online image search for the term AI and see what kind of images come up. If you're using Google search, you should choose images in the top of the screen. We were at the peer review part. That's true. Okay, so what's the general impression you get from AI from the image search results? Is this an accurate representation of AI? Why or why not? So my answer was, my interpretation of what AI is from searching the term in an image search is that AI is robots and brains and computer circuits. This is not an accurate representation of AI because the image results from searching for AI in a search engine like Google make you think that AI is robots with computer brains. Most AI that is being used in the world today is software, for example, recommendation algorithms, LLM chatbots, and self-driving cars. All right, let's read some other people's answers over here. So the Google image search with the query AI brought us almost exclusively brains made of circuits. After scrolling down a bit, we also got some shining white humanoid robots, often in a very pensive state. The color blue is dominant. It feels... Was this answer written by an AI? The color blue is dominant. Based on this, the impression would be that AI is about tinkering with wires and circuits, trying to build an electronic brain in some modern Frankenstein spirit. Not much color, not much fun. We don't think that this is an accurate representation of AI at all. AI is about solving practical human problems in our everyday life. Better music, more interesting and important news, making new friends. Even the research side of AI, which is not what most of Google hits are about, almost never involves working with hardware such as circuits and wires. It is mostly simply about applying sound scientific principles to understanding how we can push the limits of our AI methods. It often takes a lot of talking to other researchers, writing on scrap paper, and programming. Not really much different from any other research. Okay, so let's go ahead and... So this was an answer. I guess what we need to do is we need to... Oh, this is the example answer. Okay. I thought this was an actual human submitted one. Never mind. Okay, peer reviews given 0 to 3. It's time for the peer review. Let's read the first one over here. When I search for AI in Google, it shows me images of a lot of robots, and they are using computers, mobile, and some related ChatGPT with robots. I think the perception of AI is that it can take over the world one day, but I guess it will still need someone to prompt them, so not technically possible to take all the jobs of the world. AI is artificial intelligence and not a real human intelligence. It just mimics the human brain, but not a human to solve problems like us humans. I mean, I guess we could review this. I don't think this is a particularly good answer. So answer is easy to follow. There are some parts of that answer that were a bit hard to follow. I'll give that average. Answer is well-reasoned. So they're talking about the perception of AI is that it can take over the world one day, but that's not really what the question was asking for. So, I mean, I'm not too big a fan of this. Answer is comprehensive. So they talk about AIs taking everybody's jobs. Yeah, this is kind of a mid-answer. Answer is on topic, also not really. And let's move towards the second answer. This is a really long answer. I don't want to read all this. Let's do option 2. Magical robots is how I would describe the images. AI is not magical, so no, these images are not accurate. Wow, so there are many different pictures of AI. Lots of brain-type pictures next to circuits on a robot head. I think whatever the accepted symbol for AI is way off. Okay, let's select this one. So this one, I'd say that this answer was worse than the first one. So this is not easy to follow. It was not so well reasoned. Comprehensive? I mean, they kind of stray off topic. Okay, let's do this. Alright, so, option 1, option 2. Option 2 is way too long. Let's go with option 1. When I search for AI in Google Images, the results mostly show glowing blue brains, futuristic circuit boards, glowing matrices, and humanoid robots. The general impression is that AI is a highly advanced science fiction entity that looks and acts like a robotic human. This is not an accurate representation of AI. In reality, AI is mostly invisible software, mathematical models, and algorithms running on servers behind the scenes. It powers practical, everyday tools like search engines, spam filters, and movie recommendation systems, rather than existing as physical sentient robots. This is an okay answer. I'd say let's go ahead and rate this one. Okay, so answer is easy to follow. So I understood what they were talking about here, and they say that it's not an accurate representation of AI. Yeah, I'd say that the answer is easy to follow, well-reasoned. So from what we've learned in the course, it's a pretty accurate representation of what we were learning inside this course. So let's give it a 4 out of 5. Answer is comprehensive. So they were Did they cover all the bases? So they talked about AI mostly being not physical and not robots. Highly advanced science fiction-like entities, okay? Yeah, I'd say that the answer is pretty... Based on the course, yeah, they covered all the bases there. Answer is on topic. I'd say that it was on topic, so it's a pretty good... I'd say it was a pretty good answer. Okay, so let's... So your answer has received 2 peer reviews. The average grade of the received reviews is 4.38 for my reviews. Okay, well, I mean, that's pretty good. It's 4.3 out of 5. All right, let's move on. So the societal implications of AI. The societal implications of AI. In the very beginning of this course, we briefly discussed the importance of AI in today's and tomorrow's society. But at that time, we could do so only to a limited extent because we hadn't introduced enough of the technical concepts and methods to ground the discussion on concrete terms. Grading is something not enough people do. That's true. Most people don't really have... I mean, people do reviews, but they're not usually doing reviews from like a systematic point of view. They're mostly doing like casual reviews of like products or like restaurants and stuff like that. Okay, so now that we have a better understanding of the basic concepts of AI, we are in a much better position to take part in rational discussion about the implications of Take part in the rational discussion about the implications of the current AI. I mean, I'm not too sure why this word already is in here. Okay, implication 1, algorithmic bias. AI, and in particular machine learning, is being used to make important decisions in many sectors. This brings up the concept of algorithmic bias. What it means is the embedding of a tendency to discriminate according to ethnicity, gender, or other factors when making decisions about job applications, bank loans, and so on. Okay, once again, it's all about the data. The main reason for algorithmic bias is human bias in the data. For example, when a job application filtering tool is trained on decisions made by humans, the machine learning algorithm may learn to discriminate against women or individuals with a certain ethnic background. Notice that this may happen even if ethnicity or gender are excluded from the data, since the algorithm will be able to exploit the information in the applicant's name or address. So the address might be from a city where there's a large ethnic minority, or the applicant's name might give away that they might be part of a certain ethnic group. I guess this is what we're trying to say. SysOS says, bias does not disappear just because you see an AI. Bias, well, I mean, if the people generating the data is biased, or if the data is biased, then the AI will pick up on the bias. Algorithmic bias isn't a hypothetical threat conceived by academic researchers. It's a real phenomenon that is already affecting people today. Online advertising. It has been noticed that online advertisers like Google tend to display ads of lower pay jobs to women users compared to men. Bias is everywhere, you just need to take actions to mitigate it. I mean, when you see opinions or information being displayed to you, from being presented to you from different sources, you just need to understand the types of biases that the sources are going to have. Like, for example, if you get your news from a conservative website or a liberal website, whatever news that is being presented by those websites is going to have a conservative or liberal bias. You just need to be aware of that. Okay, so lower paying jobs to women compared to men. Likewise, doing a search with a name that sounds African American may produce an ad for a tool for accessing criminal records, which is less likely to happen otherwise. That's pretty blatant, okay? Social networks. Since social networks are basing their content recommendations essentially on other users' clicks, they can easily lead to magnifying existing biases, even if they are very minor to start with. For example, it was observed that when searching for professionals with female first names, LinkedIn would ask the user whether they actually meant a similar male name. Searching for Andrea would result in the system asking, "Did you mean Andrew?" If people occasionally click Andrew's profile, perhaps just out of curiosity, the system will boost Andrew even more in subsequent searches. There are numerous other examples we could mention, and you have probably seen news stories about them. The main difficulty in the use of AI and machine learning, instead of rules-based systems, is their lack of transparency. Partially, this is a consequence of the algorithms and the data being trade secrets that the companies are unlikely to open up for public scrutiny. And even if they did this, it may often be hard to identify the part of the algorithm or the elements of the data that led to discriminating decisions. Okay, so let's see. Transparency through regulation. A major step towards transparency is the European General Data Protection Regulation, GDPR. So if you're working in cybersecurity, you hear about the GDPR all the time. It requires that all companies that either reside within the European Union or have European customers must, upon request, reveal what data they have collected about any individual, right of access, delete any such data that is not required to keep, with other obligations when requested to do so, right to be forgotten, and provide an explanation of the data processing carried out on the customer's data, right to explanation. Okay, so it says, just like with humans, bias is not often apparent from the front. I mean, yeah. I mean, you do need to know a bit about the people. You need to know people a little bit better to understand where their biases are. So the last point means, in other words, that companies such as Facebook and Google, at least when providing services to European users, must explain their algorithmic decision-making processes. It is, however, still unclear what exactly counts as an explanation. Does, for example, a decision reached by using the nearest neighbor classifier count as an explainable decision? Or would the coefficients of a logistic regression classifier be better? How about the deep neural networks that easily involve millions of parameters trained using terabytes of data? The discussion about the technical implementation, about the explainability of decisions based on machine learning, is currently intensive. In any case, the GDPR has potential to improve the transparency of AI technologies. Okay, so what is this picture of a person supposed to... Seeing is believing, I guess. Implication 2. Seeing is believing, or is it? We are used to believing what we see. When we see a leader on the TV stating that their country will engage in a trade war with another country, or when a well-known company spokesperson announces an important business decision, we tend to trust them better than just reading about the statement secondhand from the news written by someone else. Hey, Nathan, nice to see you here. Yeah. B-sides. I will be at B-sides, and I will be giving a workshop over there. But thank you very much for coming on into the LinkedIn chat. Okay, so similarly, when we see photo evidence from a crime scene or from a demonstration of a new tech gadget, we put more weight on the evidence than on written reports explaining how things look. So we tend to trust video more than we trust print media. Of course, when we are aware of the possibility of fabricating fake evidence, people can be put in places they've never visited, with people they never met, by photoshopping. So I mean, this was the way that people made deepfakes before the advent of generative AI was by using Photoshop. It is also possible to change the way that things look by simply adjusting lighting or pulling one's stomach in a cheap before-after shot advertising for the latest diet pill. Okay. AI is taking the possibilities of fabricating evidence to a whole new level. Metaphysics Live is a system capable of doing face swaps, de-aging, and other tricks in real time. Metaphysics Live, huh? I've never really seen this, but I have seen examples of this on like Instagram and TikTok. So face swaps, de-aging, or aging up. You used to see a lot of stuff like this on Instagram, I guess. There were all sorts of interesting like video filters, or like photo filters, I guess. Descript has a tool for automatic imitation of a person's voice from a few minutes of sample recording. While the generated audio still has a notable robotic tone, it makes a pretty good first impression. Okay, a pretty good impression rather. So Descript, I mean, if you're interested in taking a look at these links, I'll leave them in the chat. So this is metaphysics for doing video editing, I guess, and this is for audio deepfake stuff. SysOS says, FYI, this is known more or less. You need to explain the path the decision information transformation took. Local agencies, like for example the Dutch AP, have good resources available regarding GDPR and how it works. I mean, I guess people who are using AI have to be able to explain exactly what the AI is doing with the customer's information as part of GDPR. It's not really something I've looked too much into, unfortunately. Okay, fabricating evidence. Implication 3. Changing notions of privacy. It has been long known that technology companies collect a lot of information about their users. Earlier was mainly grocery stores and other retailers that collected buying data by giving their customers loyalty cards that enabled the store to associate purchases to individual customers. Unprecedented data accuracy. The accuracy of the data that tech companies such as Facebook, Google, Amazon, and many others are collecting is way beyond the purchase data collected by conventional stores. In principle, it is possible to record every click, every page scroll, and the time you spend viewing any content. Websites can even access your browsing history so that unless you use incognito mode or the like, after browsing for flights or to Barcelona on one site, you will likely get advertisements for hotels in Barcelona. Okay? However, as such, the above kind of data logging is not yet AI. The use of AI leads new kinds of threats to our privacy, which may be harder to avoid even if you are careful about revealing your identity. Using data analysis to identify individuals. A good example of a hard-to-avoid issue is de-anonymization. Breaking the anonymity of data that we have thought to be safe. The basic problem is that when we report the results of an analysis, the results may be so specific that they make it possible to learn about something about the individual users whose data is included in the analysis. A classic example is asking for the average salary of people born in the given year and having a specific zip code. In many cases, this could be a very small group of people, often only one person, so you'd be potentially giving data about a single person's salary. An interesting example of a more subtle issue was pointed out by researchers at the University of Texas in Austin. They studied a public dataset made available by Netflix containing 10 million movie ratings by some 500,000 anonymous users, and showed that many of the Netflix users can actually be linked to user accounts on the Internet Movie Database, because they had rated several movies on both applications. Thus, the researchers were able to de-anonymize the Netflix data. While you may not think it's a big deal whether someone else knows that you rated the latest Star Wars movie, some movies may reveal aspects of our lives, such as politics or sexuality, which we should be entitled to keep private. Okay, SysOS says, given enough data, you can identify anyone individually again. Anonymous data therefore does not exist. I mean, if you were to give people information about what kind of media I consume and the type of purchases that I make, you might be able to identify who I am. That's true. Especially if you were able to identify where purchases were being made, because I make a lot of purchases within my neighborhood, of course. Okay, other methods of identification. A similar approach could in principle be used to match user accounts in almost any service that collects detailed data about user behaviors. Another example is typing patterns. Researchers at the University of Helsinki have demonstrated that users can be identified based on their typing patterns, the short intervals between specific keystrokes while typing text. This can mean that if someone has access to your data on your typing pattern, maybe you've used their websites and registered by entering your name, they can identify you the next time you use their service, even if you'd refuse to identify yourself explicitly. They can also sell this information to whoever wants to buy it. While many of the above examples have come as at least in part as surprises, otherwise they could have been avoided, there is a lot of ongoing research trying to address them. In particular, an area called differential privacy aims to develop machine learning algorithms that can guarantee that the results are sufficiently coarse to prevent reverse engineering specific data points that went into them. Okay, SysOS says not if the GDPR applies, it prohibits such sale of data. I mean, it sounds like it's a good thing that people in Europe have the GDPR to protect them, but I don't live in a country that is covered by the GDPR, unfortunately. Okay. Implication 4, changing work. I think we're about to have an ad on Twitch, so we might be taking a little, we're going to take a little break while the ads run by on Twitch, and while the ads run, we're going to put on my favorite thing, the birds. So check out these birds. And we'll be back in about 60 seconds while the ads run on Twitch. But in the meantime, enjoy the music and enjoy the birds. Wild Radio Root, nice to see you here. And yeah, I haven't I don't show this video very often, but it's actually a very nice one. Just having a little bath. Okay, let's go ahead and get back to the course. All right, so implication 4, changing work. When an early human learned to use a sharp rock to crack open bones of dead animals to access a new source of nutrition, time and energy was released for other purposes such as fighting, finding a mate, and making more inventions. The invention of the steam engine in the 1700s tapped into an easily portable form of machine power that greatly improved the efficiency of factories as well as ships and trains. Automation has always been a path to efficiency, getting more with less. Especially since the mid-20th century, technological development has led to a period of unprecedented progress in automation. AI is the continuation of this progress. Okay, and SysOS says, I wish everybody had a GDPR equivalent protection because it's a basic human right in my view. I think privacy is increasingly becoming a big topic, especially in the last decade or so. And I think we're going to be talking a lot about keeping our data private in the future, especially because everybody's so hungry for people's data these days. Reticulum helps. Reticulum. I've never heard of that. Can you tell me what that is? Okay, so each step towards better automation changes the working life. With the sharp rock, there was less need for hunting and gathering food. With the steam engine, there was less need for horses and horsemen. With the computer, there is less need for typists, manual accounting, and many other data processing, and apparently more need for watching cat videos. With AI and robotics, there is even less need for many kinds of dull, repetitive work. A history of finding new things to do. In the past, every time one kind of work has been automated, people have found new kinds to replace it. The new kinds of work are less repetitive and routine, and more variable and creative. The issue with the current rate of advance of AI and other technologies is that during the career of an individual, the change in the working life might be greater than ever before. It is conceivable that some jobs, such as driving a truck or taxi, may disappear within a few years' time span. Such an abrupt change could lead to mass unemployment as people don't have time to train themselves for other kinds of work. The most important preventative action to avoid huge societal issues such as this is to help young people obtain a wide-ranging education. This provides a basis for pursuing many different jobs, which isn't in high risk of becoming obsolete in the near future. It is equally important to support lifelong learning and learning at work, because there are going to be few of us who will do the same job throughout their entire career. Cutting the hours per week would help offer work for more people, but the laws of economics tend to push people to work more rather than less, unless public policy regulating the amount of work is introduced. Okay, Wild Radio Root says, Network Stack, the I2C interface, is a physical layer module that allows your node to connect and communicate directly with microcontrollers and peripherals over a local mesh. So physical layer module, your node. Olive Tree Lover, hello, nice to see you here. People are going to move to underdeveloped countries to find jobs. I don't know if that's true or not. Hello, Olive Tree Lover. I2C I squared C. I squared C. It's a two-wire protocol. Is this like an Internet of Things kind of technology, or I'm not really too sure what this what kind of technology this is. Wild Radio Root says it's the 1990s West Coast anarchist idea of the internet. Oh, so it's like a... Oh, okay. Embedded technology. Alright. Anyways, so because we can't predict the future of AI, predicting the rate and extent of this development is extremely hard. There have been some estimates of the extent of job automation ranging up to 47% of US jobs being at risk, reported by researchers at the University of Oxford. The exact numbers, such as these, 47%, not 45 or 49. The complicated sounding study designs used to get them, and the top universities that report them, tend to make the estimates sound very reliable and precise. Recall the point about estimating life expectancy using a linear model based on a limited amount of data. The illusion of accuracy to 1% is a fallacy. The above number, for example, is based on looking at large numbers of job descriptions. Perhaps licking the tip of your finger and putting it up to feel the wind, and using subjective grounds to decide which tasks are likely to be automated. It is understandable that people don't take the trouble to read a 79-page report that includes statements such as, the task model assumes for tractability in aggregate, constant returns to scale, Cobb-Douglas productive function. However, if you don't, then you should remain somewhat skeptical about the conclusions too. The real value in this kind of analysis is that it suggests which kinds of jobs are more likely to be at risk, none in the actual numbers, such as 47%. The tragedy is that headlines reporting nearly half of US jobs at risk of computerization are noted. The rest are not. Okay? Olive Tree Lover says the only solution for this is to add huge taxes on companies who mass fire employees to favor AI. I mean, yeah, it's really hard to say how we resolve this kind of problem, because as a boss, as a company whose primary function is to make as much money as possible, they are going to tend towards adopting new technologies that are going to reduce the number of people that they need to employ, because the number of people that they employ directly goes against the amount of money they earn at a profit. Okay, so let's see. Olive Tree Lover says AI companies and big tech are going to have all the money, and we are going to be put to work. That's just a matter of time, no more, no less. SysOS says, let's not forget all companies need people to buy products. If people cannot buy products, businesses will suffer. Let's see. Olive says, if governments don't do stuff to stop this, we are doomed. I mean, I'm pretty sure that the governments that do put in protections are going to cause companies to move away from those countries, and those companies are just going to set up shop in a country that doesn't have those protections. We've seen this kind of stuff happen all the time. And Warlock Gaming, hello, nice to see you here. Hope you're having a good time. Okay, so then, what actually are the risks that are more likely to be automated? What actually are the tasks that are more likely to be automated? There are some clear signs concerning this that we can already observe. So, autonomous robotics solutions such as self-driving cars, including cars, drones, boats, or delivery robots, are just at the verge of major commercial applications. The safety of autonomous cars is hard to estimate, but the statistics suggest that it is probable not quite yet at the required level. It is probably not quite yet at the required level, the level of the average human driver. However, the progress has been incredibly fast, and it is accelerating due to the increasing amount of user available data. And hello Ignifer, nice to see you here. So customer service applications such as help desks can be automated in a very cost-effective fashion. Currently, the quality of service is not always to be cheered. The bottlenecks being language processing, the system not being able to recognize spoken language, or to parse the grammar, and the logic and reasoning required to provide the actual service. However, working applications in constrained domains, such as making restaurant or haircut reservations, spread up constantly. And Theo, B Theo has rated me with a party of 33. Hello, Raiders. And hello, B Theo, nice to see you here. Coming in hot. Let's give Theo a shout out. Theo also does cybersecurity and information security content on Twitch. And if you're not following their channel, what are you doing? You should go and follow it. Riffraff Inbound. Hello, guys. We're currently taking an AI course over here. It's called Elements of AI, and we're talking about the implications of AI. This is kind of like the end of the course. But what was Theo covering on his channel? Was he doing more Hack the Box rooms or something else? Okay. So autonomous robot solutions, customer service applications, these are things that the AI is good at doing. Well, I mean, the robotic solutions, they're not quite there. They're not quite, well, I mean, if we're talking about like autonomous cars, they're not yet at the level of the average human driver, but they may get there within a few years, or maybe like a decade or so, not sure. Is the ad part over? I'm not too sure what you mean by the ad part. Thank you very much for following on Twitch. Marcin Matrix, thank you. Or never get there at all. I mean, yeah, I mean, nobody can really predict the future, but... Martin, oh, okay. Martin, nice to see you here. Okay, so for one thing, it's hard to tell how soon we'll have safe and reliable self-driving cars and other solutions that can replace human work. In addition to this, we mustn't forget that a truck or taxi driver doesn't only turn a wheel, they're also responsible for making sure that the vehicle operates correctly. They handle the goods and negotiate with customers. They guarantee the safety of their cargo and passengers, and take care of a multitude of other tasks that may be much harder to automate than actual driving. Okay. Oh, it's a Polish name, okay. Warlock Gaming, Active Directory. The Active Directory part of the stream is going to be at the end of the stream. So if you're looking for that, I think you might want to come back in about 3 hours. In about 3 hours, and we'll be covering the Active Directory stuff then. Or maybe like 2.5 hours. SysOS says there's no given that the current self-driving will ever get to the level where it can work in a human mixed environment. I mean, human mixed environment is like the key word there. The AIs would be very... They could probably do okay driving in an environment where they only have to deal with other AI drivers and maybe like animals. Not completely sure. But let's see. So as with earlier technical advances, there will also be new work that is created because of AI. It is likely that in the future, a larger fraction of the workforce will focus on research and development and tasks that require creativity and human-to-human interaction. If you'd like to read more on this topic, see, for example, Abranev's series Nice Essay on Artificial Intelligence and the Rise of Economic Inequality. Well, I mean, you can take a look at the link over here. Warlock Gaming says, AI in the first place will mostly need humans to run them for inputs, but after the grip gets better, AI will do everything without the need for humans. I mean, I'm not... yeah, it's... I think for right now, AIs do need people for input and for prompts. But who knows where it's going to go in the future. Okay, we got an exercise to do over here. 2017, I think I read this already. Oh, really? Okay. Exercise 24, Implications of AI. What kind of articles in newspapers and magazines and other popular science outlets such as blogs are being written about AI? And do you think they are realistic? Do an online search about AI related to one of your interests. Choose one of the articles and analyze it. They really want us to do some real research for our exercise here, huh? Oh, you read that one already, says OS Master. Okay. Okay, mention the title of the article along with its author and where it was published as a URL applicable in your answer. Explain the central idea in the article in your own words, using about a paragraph of text. Based on your understanding, how accurate are the AI-related statements in the article? Explain your answers. Are the implications, if any, realistic? Explain why or why not. Okay, on using ChatGPT and similar models, we appreciate you putting an AI tool into use. Feel free to consult it, but note that since we are interested in your own opinion, we expect you to write the final answers yourself. Your answer should be about 20 words. Okay, so what do they want us to do? Do an online search about AI related to one of your interests and analyze it. Okay, so, I mean, we're doing hacking stuff, right? So we probably want to learn about an article that talks about AI and doing like pen testing or something. So let's do a little search. AI-powered cybersecurity pen testing. Okay, so we've got, so we're looking for an article, right? So we might as well put the word article in here. Okay, so we got CrowdStrike. AI accelerates cyber attacks. I mean, maybe not exactly what we're looking for. Okay, Nitro Based. Hello, nice to see you here. How can I learn like you for long hours? Oh, okay, so OS Master has a link. So Nitro Based, if you want to learn about the basics of cybersecurity, we've got a little website called Get Into Cyber, which you might want to take a look at. Okay, so yeah, let's take a look at the link over here just a second. EC console, cybersecurity, ethical hacking, AI pen testing, ethical hacking. Oh, okay. All right, let me take a look at these articles first. And there's another one. I mean, I guess we could... The Medium article is probably going to be a little bit less dry than some of the university ones. So maybe we'll take a look at this one. How much time do we have? 15 minutes? Warlock Gaming says, I think the coming of AI is God's answer to stop the oppressive higher position managers who take advantage of employees by asking them to work for more and more time, apart from the usual working hours. I mean, I'm not too sure what the tech industry looks like at the very, large company levels. Okay, let's take a look at this article here. The role of AI in the future of penetration testing. Where is this? So this is from last year? So it was from about a year ago. A game changer for ethical hackers. So let's see. This is an article by Mohammed Suleiman. And let's take a look at the article real quick. So as the cybersecurity landscape continues to evolve, so do the tools and techniques used by both attackers and defenders. Among the most transformative technologies making waves in the industry is artificial intelligence. While AI is already being leveraged in various areas of cybersecurity, such as threat detection and behavioral analytics, its role in penetration testing is rapidly emerging and poised to reshape how ethical hackers operate. So, AI is not a replacement, it's a force multiplier. So this is something that I talk about when I talk about how AI is affecting the cybersecurity industry. It's gonna be that one person with AI assistance is going to be able to do more work than one person without AI assistance. Okay, so let's see. Warlock says this is not the case for European and American countries. It's mostly Asian countries that abuse work culture. I mean, everybody's heard about the insane work culture of countries like Japan and South Korea and China. Nikeva, hello, nice to see you here. Finally made it to a live chat while you're online. Hello, nice to see you here, and hope you're having a good Friday. Okay, so one common misconception is that AI will replace penetration testers. The reality is far from that. Penetration testing involves creativity, context-based judgment, and human intuitions, areas where AI still falls short. However, what AI can do is augment the capabilities of a human tester by automating repetitive tasks, improving accuracy, and providing real-time insights. So here's how an AI is likely to assist pen testers in the near future. So number one, automated reconnaissance. Reconnaissance for the first part of any pen test often involves hours of scanning domains, subdomains, open ports, services, and public data. AI can significantly speed up this process by automatically identifying patterns in DNS records, certificates, and metadata, prioritizing high-value targets using historical exploit data, adapting its scanning techniques based on network responses, and this allows pen testers to focus more on analysis and exploitation rather than data gathering. I mean, I can certainly see that because people have already been doing stuff like this with automation scripts. So they'll do like a reconnaissance script, and there have been like well-known scripts for doing like network-based pen testing automation. So stuff like Tiberius. I haven't seen Tiberius online in a long time. So Tiberius made a tool called AutoRecon, I think. Yeah, this one over here. And this was an automated, I think it's like it's Python based. It's a Python based script that can be used to open mass. AutoRecon? Never. No, nobody would ever use AutoRecon. I actually used AutoRecon when I did my OSCP exam. So when I did my OSCP exam, this was 4 years ago? No. It was more than, it was like 5 years ago at this point. So I did, I used auto recon to scan the networks that I was pen testing during the OCP exam. Nice work, bro. Hello, Hacker Jute. Nice to see ya. I hope AI will change this culture. Which culture? Work culture in Europe and in Americas is different, but abuse and exploitation is rampant in all, although they are different. Okay, so let's see. Is he the same Tiberius who made the famous Linux Privest tutorial? I think it's probably the same guy that you're thinking of, but I don't see Tiberius's name here though. Yeah, this guy. So this is Tiberius used to be a very frequent live streamer. He used to do like Twitch streams and YouTube streams as well, I think. Anyways, here's his GitHub. Anyways, let's keep on reading the article. So number 2, vulnerability identification and prioritization. AI can integrate with existing vulnerability scanners to correlate CVE data with system configurations, eliminate false positives using contextual data, predict which vulnerabilities are more likely to be exploited in the wild. This is a huge advantage in large enterprise environments where sorting through dozens of scan results manually can be inefficient. Okay, number 3, exploit generation and customization. AI-driven models, especially those trained on exploit databases, may one day generate proof-of-concept exploits for known vulnerabilities, suggest payloads variations for evasion, automate privilege escalation paths on misconfigured systems, and while these tools will still need human oversight to ensure ethical and safe use, they can drastically reduce manual research time. Okay, number 4. Bypassing defensive mechanisms. Advanced AI can simulate evasive tactics by observing endpoint behavior in real time, modifying payloads to evade EDR and XDR detection, using generative AI to craft phishing emails, fake login pages, or deepfakes in red team engagements. This mirrors the cat and mouse game between attackers and defenders, and AI helps the pentester stay ahead of the curve. Number 5, documentation, reporting and documentation. So this is probably something that really gets taken advantage of by the people who are doing penetration testing, because the reporting and the documentation is easily some of the most tedious parts of doing pen testing. And I'm wondering, Sick in the Mind is a person who does pen testing on web apps and networks. I'm wondering if you use a lot of AI to write reports, and how much time it saves you in writing those reports and doing the editing and the fact checking and all that other stuff. Sick is a legend. Agent 57. Hello. Yeah. Okay. Warlock Gaming says, will AI be better in defensive or offensive? I mean, that's hard to say. It definitely has a place in both. Okay, one of the most time-consuming parts of pen testing is creating reports. AI can assist by... Sick in the Mind says, not yet, I work with a lot of red tape. Oh, they restrict your use of AI to only specific things? I mean, it makes sense. They want to make sure that, especially like cloud AI models, don't get access to sensitive customer information. But I suppose if you had like a specific company, like LLM that you could use, then you would be able to feed it customer information without worrying too much about data leaks. Okay, data classification doesn't permit any of the data to have access to restricted data, which is all pen testing. Yeah, that makes sense. Okay, auto-generating executive summaries and technical write-ups, inserting screenshots and command logs into structured formats, tailoring reports to different stakeholders, technical versus business. This enables testers to focus more on testing and less on paperwork, while ensuring clients get clear, actionable findings. Ethical considerations. With great power comes great responsibility. The use of AI in pen testing must be controlled. AI should never be granted unrestricted execution privileges without human review. Transparent. Reports should disclose when AI-generated data or insights are used. And compliant. Adhering to local boundaries like the Computer Misuse Act, UK, or CFAA, US is essential, especially if AI tools act autonomously. Plextrack? Oh, is that like an AI powered document writing tool? It's a reporting tool, okay. The future. Human-AI collaboration. In the coming years, the most effective penetration testers will be those who understand how to collaborate with AI, not fear it. Much like how modern developers rely on GitHub Copilot or IDE plugins, pen testers will work side by side with intelligent assistants that suggest payloads, recommend attack paths, summarize logs and results, offer remediation guidance, and think of AI not as a tool, but as a junior analyst that never sleeps. Okay. Final thoughts. The future of penetration testing is not AI versus humans, it's AI with humans. Those who embrace the synergy will lead the next generation of ethical hackers, capable of navigating complex environments with greater speed, precision, and impact. AI won't make you obsolete, but ignoring it just might. And never thinks. It never sleeps and it never thinks. Okay, we're finally in the RoboCop as an option era. RoboCop as an option? Alright, I think we've got an ad that's going to be running on Twitch any second now, so we're just going to take a break for a little bit of water. And in the meantime, you can check out the birds. How about... these birds? Okay, we'll be back in about 60 seconds, but enjoy the music and enjoy the birds. Yeah, this guy's super curious about the camera. Sick of the Mind says, I'm still convinced that those guys at Pocketos gave Claude permission to run any command in their database client tool, which resulted in deletion. I mean, this... You know, even for pen testers, you don't usually give pen testers access to the production version of your web app if you can help it, right? Huey says the truth is that he can give you inspiration, but he won't replace a human being. Are we talking about? We're talking about AI, right? Anyways, let's put the birds away. Let's get back to the hacking. Okay, AI won't make you obsolete, but ignoring it just might. I mean, there's some people that I know who absolutely won't touch anything AI because they're protesting the ethicalness and the environmental impact of it. The thing is that you're just kind of like handicapping yourself if you tell yourself that you absolutely won't use AI to assist you in any way. Okay, hello, free Worm GPT. Free Worm GPT? Is that something you can get from like a random link? Anyways. So we got a couple minutes left. SysOS says, that's a burn ship that has sailed, sunk, and won't get revived. Worm GPT free? I mean, I've never really looked into it. Okay, let's, where were we? So choose one of the articles and analyze it. Mention the title of the article along with its author and where it was published as a URL if applicable in your answer. So the title of this article is called "The Role of AI in the Future of Penetration Testing, a Game Changer for Ethical Hackers." Okay, we will mention it over here. And then we will give the URL. Okay, SysOS says, let's second the mind says, same mentality, new generation. SysOS says, the objections against how LLM got trained and not using AI due to it. Okay. Second the mind says, it's like those old mechanics, they only work on cars before computers were the main driver. Yeah, that's true. KK1 Darnock, hello, nice to see you here. What were you reading? So we're reading this Medium article that talks about AI and pen testing, ethical hacking, and we're doing that as part of a course over here on AI, because we need to learn about it, because people won't stop people won't shut up about AI, so we need to learn this stuff. Whoops. Okay, here's our link. And let's see. Mention the title of the article, explain the central idea of the article in your own words, using about a paragraph of text, multiple sentences. Okay, explain the central idea in the article. So this article speaks about the role of AI assistance in cybersecurity penetration testing. That is attempting to test the security of a computer network or web application by analyzing it and attempting to exploit any security flaws identified by the analysis. Okay, and what else? So what kind of course is it? I feel like I'm missing the context. So the course, it's a beginner level course that talks about the broad context of what AI is, and explaining about how AI comes to the conclusions that it does. I'd say it's a pretty good course, especially for beginners, because it introduces people to a lot of the terminology that we talk about when we're discussing AI. So, anyways, I'm gonna save this because I'm not gonna be able to complete this article right now. Or sorry, I'm not gonna be able to complete the exercise right now. I'm gonna have to come back to this. So I'll just keep it in the background here, and we'll move on to the next part of today's stream. Okay, so we're not going to submit this, but we are going to move on to the next part of today's stream. So the second topic we're doing today is OLIcyber. So OLIcyber PCAP Forensics. So what we're doing now is we're going to move on to some cybersecurity challenges. Oh, you know what? I noticed that my overlays were wrong all this time. So we are finished with topic 1. Topic 2 is here. Topic 3 is on deck. Okay, so OLIcyber is an Italian cybersecurity education website, and you can access it by making an account over here. So even though the website is entirely in Italian, because we've got access to great browser features such as translation, so we can go and we can translate a page from Italian to English, for example. This gives us access to a lot more resources than we would normally. So I highly suggest everybody to look for to look for good education resources that are not only in your language of choice, but other languages as well. Because I mean, translation, which is an AI method, has gotten really good. Anyways, we're going to be doing some challenges from this category over here. It's called network security. So network security on this website mostly has to do with packet captures, so network traffic analysis. So we're going to be doing this challenge over here. So we've worked through a bunch of these challenges already, and we're on the 9th one in this introduction series. Why not from Italian to a more fun language like Frisian? I do not. Frisian is like a dialect of Dutch, isn't it? Is that why you're talking about it, SysOS Master? Okay. Alright, so what is this? So this is network challenge number 9, deciphering TLS traffic. To solve this challenge, you will need to decipher the traffic TLS using the file containing the log of the keys used. The log of the keys used. Once traffic has been successfully decrypted, Wireshark will automatically recognize the contents of the encrypted packets. The flag is in the request header get with OLIcyber.it something something. Okay, so we've got TLS keys, and we also have a packet capture file that we can look at. Okay, is the person who made the comment Iranian? I'm an Iranian hacker. The person who made the comment? Which comment are we talking about? SysOS says it's not a dialect, it's its own language. Oh, okay. Okay. So let's see, ZB says, or take it to the next level and learn Italian while learning cybersecurity. Learn Italian while learning cybersecurity. I mean, I hear that the Italian cybersecurity scene is pretty, there's a lot of interesting people working in the Italian cybersecurity scene, so I've heard. But anyways, if you want to do this challenge specifically, you'll have to be logged into OLIcyber. Actually, you might be able to download these files without being logged in. Let me check. You can download these files without being logged in. So if you want to take a look at the same PCAP file that we're going to be looking at, so there's the first link, and where's that second link? So the second link is the TLS keys. I've never really dealt with TLS keys before, but I guess this is the first time. Darnock says, what other countries do you think have a strong cybersecurity teams, or whatever you want to call it? I mean, what countries have a strong cybersecurity culture? I guess we can talk about that real quick. Okay, countries with strong cybersecurity culture. So I'd say that the USA is a country with strong cybersecurity culture. The UK is also has pretty strong cybersecurity culture. I hear that Brazil. So countries like Brazil, countries like Russia, of course, China, what other? South Korea. No link to the second part? Oh, the second part. Sorry, let me give you the link to the second part. Second part is over here. Iran? And let's see. So USA, UK, Brazil, Russia, China, South Korea, Iran. I'm not too sure what other European countries have like a strong like cybersecurity culture. Italy? I mean, Italy, probably France, if I'm to guess. And CCC is based in Germany, so I'm guessing that Germany also has like a strong cybersecurity culture. Romania. I mean, I haven't heard of Romania, but I'll believe you. The Netherlands, Germany, Israel. Oh, Israel, of course. Israel. Okay, Finland, Iceland, Finland, The Nordic countries. Iceland. I don't know about Iceland and cyber. I mean, I'm not completely too sure myself, but I'd say that the countries at the top of this list have very strong cybersecurity cultures, and of course Israel. Anyways, let's keep on going. So we've got our two downloads over here. What we need to do is we need to decipher the TLS traffic using the file contained with the log of the keys used. So, I mean, I've never really done this in Wireshark before, so I guess we're going to have to learn how to do it. So I'll call this terminal, we'll call it OLIcyber. Sure. We'll make a directory for this. So this is network 9. Okay, so we need to move the 2 files that we downloaded over here. And there was the key file as well, right? TLS keys. Okay, she probably said a warning that OLIcyber will kick you off the platform if you're doing any other live CTFs and you're not a student. That's probably that's a good disclaimer there. Don't use. Whoops, I have the caps lock on. Don't take part in live OLIcyber events if you're not a student. They may ban you. Okay, unless you're a high school student in Italy. Italian high school student. Follow the rules of the CTF that you're doing. Yep, that makes a lot of sense. Okay, so let's go ahead and boot up Wireshark. So we need to decipher the traffic in the TLS traffic. Let's get to it. So we're going to run Wireshark on this thing. Okay. Stone Eating Guy. Hello, nice Stonk Eating Guy. I'm pretty confused with this one. I'll try my best. I mean, we're trying new stuff over here because we haven't really dealt with deciphering TLS traffic before. Okay, how did you even find this Italian website? Was it recommended to you by someone, or did you just mess around and find it accidentally? So occasionally I look at different websites, and different websites usually have recommendations for other websites. For example, if I go to hackmyvm.eu, this is a website that I've used a lot in the past. And on this website, they've got a bunch of links at the bottom of the page where they recommend other cybersecurity websites. Down over here. Stonk. Yeah, no worries, Stonk. But they've got a bunch of links over here, and I just pick up these cybersecurity websites over time. Of course, there are probably hundreds of other cybersecurity websites that I don't know about, but I've found stuff from a bunch of different countries, strangely enough. So I found Italian cybersecurity websites, I've found Russian cybersecurity websites, and German ones. So we're just talking about like non-English speaking countries. So I've also found like a French one. So I mean, it really does pay to look into the resources of other countries, because I mean, use all the resources you can, obviously. Okay, so where are we in Wireshark? So we're in Wireshark here, and how do we decode TLS using a key file? So I probably need to research that. using Wireshark to decrypt TLS using a key file. So to decrypt TLS traffic in Wireshark using a key file, you must have two primary methods. Using a pre-master secret log file or an RSA private key. The master secret method is easiest and supports all modern cipher suites. I wonder what kind of you load the keys? Oh, I just need to know where in the interface we load the keys. Actually, let's see. Let's do this in the research tab. Okay. Do you maybe have the French one around to link? Doesn't need to be right now, of course. I mean, getting the... That's HackerPol. HackerPol.fr. So if you want to take a look over here, there's an English version of this website as well. But if you speak French, then it's a good resource for you. Okay, so back to trying to decipher this thing. What we wanted to figure out was what kind of key we have. So file TLS keys. So this is just ASCII text. Server handshake traffic secret. Client traffic secret. Exporter secret. Okay. So this is probably a pre-master secret log file. And it's probably not an RSA private key, because I know what RSA private keys look like, and the stuff we were just looking at wasn't that. So this method intercepts the session keys generated by browsers like Chrome or Firefox during traffic negotiation. Set the key login environment variable before launching your browser. Okay? So how do we load it into Wireshark? Configure Wireshark. Open Wireshark and go to Edit Preferences Protocols TLS. Locate the file, click the Browse button, and then click OK. So Edit Preferences Protocols TLS. Kali Linux, my favorite distro to check my package manager about deployment packages. I mean, the reason why I use Kali Linux is because all the tools are here and I don't have to search around and figure out how to install all of them. I guess I haven't moved past that step in my hacking journey. Okay, so Wireshark, what were the steps? Edit Preferences Protocols. Edit Preferences Protocols. TLS. I guess we need to go down to TLS. There we go. TLS. And we need to pre-master secret file log name. I guess we can plug this in. And there's also a TLS debug file. I'm pretty sure we're talking about the master secret log file name thing. Okay. Docker. Oh, there's also a Docker version of Kali as well, that's true. So we'll try this tlskeys.txt file here. And then click on apply. Did that change everything? Master secrets log file. Okay, so I think we've loaded it in. So what we need to do now is take a look at the challenge. Once traffic has been successfully decrypted, Wireshark will automatically recognize the contents of the encrypted packets. The file is in the request header of a GET, so HTTP GET for OLIcyber.it. So we need to do the filtering. So http.get, no. HTTP method. Well, first we'll just do HTTP, and then we'll filter further on that. Can I make this bigger? A little bit bigger. So HTTP and So how do we filter on the get method? Wireshark filter on HTTP method. I need to look this up like every time. Okay, HTTP.method request.method == get. So that, that just filtered everything. That's not what we want. There are no packets? Hold on. So protocol is HTTP2. HTTP2, I mean, there's not very many of these. Probably not a valid expression. Okay, so HTTP, I mean, did it lie to us? HTTP.request.method. Okay, let's go back in. HTTP.request.method. It's in here. There are no get in double quotes. That's, I mean, that might be it, yeah. No, still not it. Or put in HTTP2. How about just HTTP? HTTP doesn't return anything either. HTTP2? HTTP2 does return stuff. Okay. HTTP2 dot headers method get. Okay. HTTP2 dot headers dot method dot, well, == get. There's only one. Okay, there's only one, so that's good. So this probably has our flag inside. It seems like this is encrypted. So decrypted TLS, oh, this is the frame. The decrypted TLS is here. Decompressed header. Okay, okay, we managed to find it. We managed to find it. Okay, flag, secrets, keys are your friend, are no joke, great. I think we can copy this. Copy as ASCII text. Okay, and then we can go back to, I don't know, our text editor and just paste it in. Flawed paste. It didn't manage to copy this. What happened? So copy bytes as, let's just copy it as a hex dump and just paste it in. Nope. That doesn't get us our that doesn't get us what we want. ASCII text, I mean, yeah, let's try ASCII text next. So this is copy as ASCII text. Yeah, it doesn't like this. We'll try copying it as UTF-8 or hex string. Follow TCP stream. Probably, yeah, that's probably the better way to do it. Okay, so we'll follow the TCP stream. Or actually, maybe we'll follow the TLS stream. Nope. Actually, wait. Maybe. So the TLS string is this. But let's try following the follow HTTP2 stream. Okay, this also gets us what we want. Still got to code that. Yeah, but I don't see the flag in here though. Oh, no, it's here, Okay, so the flag is is from the server. So can we select all? I don't want to select all. Can we show this as, not as a hex dump, but as ASCII text? So we select as ASCII. Here we go. Okay, awesome. So we just need to copy this and submit this as the flag. All right, so what we're going to do is we're going to do a little write-up on this because we want to know how we did this, and if we need to do this in the future, what steps we took. So let's go ahead and, well, first of all, we'll submit this as the answer to the challenge. Okay, and then we can do our write-up. Why do we do a write-up? Well, for all the reasons we talked about before. A little hurdling, I mean, it's not really a challenge if you're able to do it very easily. Okay, so this is OLIcyber, walk through OLIcyber. So I keep track of all of the challenges that we've solved on the stream. Well, not all the challenges, but a lot of the challenges that we solve on stream we like to keep track of, so that we can come back and look at the stuff later. So this is Network 9, Network Challenge 9. Okay, because the AI did not already do it for us. I mean, one of these days we're not going to have access to the AI, and sometimes looking it up with AI takes more time than looking at your own notes. The AI is very good for doing research, but we shouldn't be overly reliant on it, because we don't always have access to it. Okay. Run it locally, problem solved. Maybe. Okay. So we're going to record some different pieces of information for this challenge. So for this challenge, we'll record where the URL of the challenge is, so where we can access it. We're going to record the concept we learned, or the concept you need to understand to finish this challenge. And we've got ads running on Twitch. When ads run on Twitch, we also take a little break, because we have to stop and let the ads run by on Twitch. But in the meantime, you can watch these birds and listen to the music. We'll be back in about 60 seconds. I mean, the birds are for people who don't have to watch the ads. But for the people who have to watch the ads, well, we're just taking a little break so that you don't miss any of the action. So there are a lot of these gray squirrels. The squirrels in your country probably look different from the ones over here. I'd say that the type of squirrels that we have over here are probably like the least cute looking types of squirrels. Anyways, let's get back to the hacking. They used to be red. Well, I mean, they used to be gray, but for some reason a lot of the squirrels in North America, they melanized and they turned a very, very dark color. They used to be red, but yours killed them all. The eastern gray squirrel. The eastern gray squirrel, are eastern gray squirrels like from Europe? Hold on, I need to look this up. Eastern gray squirrel. Native range. So this is the type of squirrel we have here, the eastern gray squirrel. These are North American? Okay, native to eastern North America. So these are, yeah. For some reason, I think they got imported into Europe, where they become an invasive species. American gray squirrels are invasive species here. Yeah, so they're not they're native to my country, but they're an invasive species in other countries. Okay, let's go back. So we were writing up doing our write-up over here. So the concept for this challenge is using a, what did they call it again? So this was like edit, preferences, protocols, TLS. And this was a pre-master secret log file name. Pre-master secret log file name. Pre-master secret log file to decipher TLS in packet capture or PCAP files. Okay. Making me hungry for some squirrel. I mean, I don't know what squirrels taste like, and I've never really heard about people eating squirrels. They probably taste better than rats at any at any rate. Using a pre-master secret log file to decipher TLS and PCAP files, and that's it. That's what we learned in this thing. Okay, so method of solve. So we download both the PCAP file and the pre-master secret log file. Open up Wireshark and select, do you teach? Do I teach? I teach some. They taste nutty, or so I'm told. Panacopanco, squirrel eating stream when? Panacopanco, hello, nice to see you here. Did you know that Panacopanco is another InfoSec streamer? Let's give her a shout out. And I hope you're doing well, Panacopanco. Last I checked, you were doing a lot of 3D modeling commissions. Okay, open up Wireshark and select. What was the thing? I'm sick, but I'm still doing commissions. I hope you get better soon, Panacopanco. Okay, so it's what was it? Edit, preferences, protocols, TLS. Let's just confirm that. Yeah. And then click on pre-master secret log file name. Okay, then select the file. And afterwards, are you streaming on LinkedIn? I am streaming on LinkedIn. Hey, Kevin Johnson, nice to see you here. Keep doing an excellent job. Awesome, awesome. How are you doing, Kevin? I remember that one time you asked me to do a talk with your students, and I hope they got some good stuff out of it. Anyways, so select the file, and then all of the TLS packets should be decrypted. And then what do we need to do? Use the following filter to see only the HTTP packets with a get method. Okay, and we'll include the filter over here. What was it again? So it's like HTTP2 header method get. This one. Okay, Red Sly Fox, I had to leave IT for a different industry to make any money. I'm sorry to hear that, Red Sly Fox. I mean, if you're passionate about IT, then hopefully you can return to IT again sometime. D8 says, it's cool that you're streaming on LinkedIn. Are you using something like StreamYard to hit all these bots simultaneously? I'm using a service called Restream. Restream.io. It's a pretty well-known one. Okay, Kevin Johnson says, they loved it. We'll be reaching out to you again for the upcoming semester. Just, yeah, go ahead and reach out to me on LinkedIn or any other method is fine. And Supreme Overlord, hello, nice to see you here. Okay, so we do the filter. Follow the conversation for HTTP2. Then select view, what was it? Follow HTTP2 stream, and then show as ASCII. Show as ASCII. And the flag should be at the top of the convo. Done. Finis. Okay, and Alice Adari, hello, nice to see you here. Cypher says, I feel like I have to give up on IT because degree expired and barely able to get any experience. I mean, a lot of people pivot into cybersecurity from doing like entry-level jobs in cybersecurity, like system administration and stuff like help desk. So maybe try getting one of those entry-level jobs, and then you might have some better luck pivoting into it from there. Okay, are there any other challenges? Yeah, we'll do one more challenge after this. So let's see. So there's a write-up, and degree. So Sick of the Mind says degree expired. I think they're talking about a certificate, probably not a degree. Usually degrees that you get from school don't usually expire. So where were we? Okay, so we're doing the next challenge, which is challenge number 10. So this is export objects. We've done a lot of this, but let's do the challenge. Okay, so the challenge is over here, and so to anybody who wants to do this themselves but doesn't have an account over at OLIcyber, I'll just leave the link for the PCAP file we're going to be looking at. Yeah, hopefully you can download this. Okay, so we'll just exit from Wireshark because we want to open up a new file. So network 10 is the challenge we're doing. Oops. And let's download that file. Actually, I think we can W-get it. Did we get it? Nope, I don't think we did. Alright, let's delete this. Okay, we'll just click on the thing then. Cypher says, bachelor's degree not officially expired. After 5 or 6 years, I feel it's not considered relevant. I mean, what is the bachelor's degree in? Okay, so let's see. Yeah. Cypher, are you part of the HackerFrogs Discord? Here it is over here if you want to join. Vicky Memes, hello, nice to see you here. What are we doing? So we're currently doing a PCAP challenge. So we're looking at packet capture stuff over at OLIcyber.it, and we're going to be... What are we doing here? This challenge shows a simple method for extracting files and other objects contained in a known protocol package. For example, HTTP, FTP, etc. To solve this challenge, you must extract a PNG object from the HTTP package and then read the flag in the image. Read the flag in the image. Okay, well, it should be fairly straightforward to do. I'll show you how to do it. So we'll just move the packet capture into this directory first. Okay. And then we'll open it up with Wireshark. Okay, so Wireshark, this thing, and so inside of the packet capture, there might be files. Embedded into the packet capture file. The way we want to extract them is by going over to File, and then Export Objects, and then HTTP, or whatever protocol was used to download the files. So Export Objects HTTP, and we see here that there is a... They told us that there was a PNG file in here. Well, it's probably this one, right? Multi-part form data. Okay, so this one's selected. Can we save this as? Can we save this? So click on Save. And this is just an HTML file. Okay, so the HTML file doesn't help us too much. So we can take a look at the MIME multi-part media encapsulation over here. So it says that this is supposed to be some sort of PNG file, huh? I think we can extract this, or we can, what is the word? We can export it. So hypertext protocol, response in frame 12. Response in frame 12. Okay, so if we click on this, it goes to frame 12. And this is our... So if we click on this, can we edit, like... export packet, export specified packets as something something? Because I don't see the PNG file here. The challenge tells us that we have to extract a PNG object from an HTTP package. Extracting object from HTTP packet. Maybe we need to look this up. Wireshark extract file from HTTP packet. Okay, to extract a file from an HTTP packet in Wireshark, the most efficient method is the export objects feature. I mean, I thought we... Okay, let's go back in. There might be something I'm just missing here. Export objects HTTP, but the file name is HTML. Maybe the file name is HTML, but it's actually non-HTML. We'll try saving this as upload HTML, and we'll just take a look at the file. Okay, so this is data, right? Let's just XXD this and take a look at what it looks like. Okay, content disposition form image file name flag.png. So this is the raw data, but it doesn't have. I think what we want to do is we just want to get rid of everything up until this point, because this looks like this part of the file is probably where the PNG starts. So let's try editing. What's a good hex, like hex edit maybe? You got the full upload, there'll be an ending separator, with a dot. Hex edit? Let's hex edit upload.html. Okay, can we just delete these? Because I'm pretty sure, right. So this is the PNG contents over here. We just need to get rid of the footer and the header. There should be a header and a footer. So the 2Ds here, we just need to okay. Hex edit. Delete byte. How do we delete bytes in hex edit? Okay. Many common hex editors operate in overwrite mode by default and may not support true deletion, which changes the file size. So to delete bytes, highlight the desired section and press delete. So the other thing we could do is we could go in with not a text editor, but a regular text editor. So go in with it with like Nano. And just get rid of everything up until here, because these are the magic bytes for the PNG file. And then move down to the bottom here and just delete this file footer. Delete this and then save it. And we'll save it as upload.png or flag.png, I think was the original name of the file. Okay, let's see if that actually did the work. Okay, so this is data. It's not being recognized as a PNG file yet. Okay, so what are the magic bytes for the PNG file? PNG file magic bytes. So let's see. A PNG file starts with an 8-byte hexadecimal magic number, 8950. So we need to look for the 8950. So this should be picked up as a PNG file. So it's 89504E, 89504E, 47. Yeah. But our system just describes this as a data file. There's probably like a way easier way to do this. What happens if we XDG open it? Okay, so Fatal error reading PNG file corrupted by ASCII conversion. Okay, so I think something weird might have happened when we opened it up with the nano text editor. Extract the file directly from Wireshark. It's probably the better way to do it. The other thing is that there's more than one. There's more than one file here, so that might be like it might be separated out into two files. Okay, full request in URI this thing. Line-based text data. 3D Code Warrior, nice to see you here. What is up? What is up? Because this is all... I mean, there's not very much to this packet capture. There are not very many. There are not very many packets. There are only 20 of them. Export objects. There's no... I mean, this is not FTP. This is HTTP. Maybe we should be more specific when we're talking about this. So Wireshark, export file from HTTP, or export file from HTTP packet. Export objects feature. So we don't want to use the export objects feature because it's not really working in this case. Let's see. Exporting from a specific TCP stream. If the export objects list is empty or missing, you can manually extract it from the stream. Find the HTTP packet that contains the file, right-click the packet, and then follow the TCP stream. In the pop-up window, change to show data as dropdown from ASCII to RAW. Okay, so it saved the RAW. I mean, that also had the HTTP information in there, but okay, let's give it a try. So here, right-click, follow. They wanted us to follow TCP stream. Okay. Follow TCP stream. Okay, so this is flag.png, and then show as raw. Show as raw. Oh, interesting. So what we see here is raw hex. The thing is that I don't think I want the raw hex. I think what I want is the hex dump. Hex dump. So this is the hex dump here. And the hex dump goes from here until here, I think. So what I'm going to do is I'm just going to highlight the entire hex dump. But not the entire hex dump. Everything that I think is the PNG file. So the PNG file... Well, let's just get this. Okay, we'll copy, and then we'll write this to a file. So this is the dump. Paste this in. But we need to clip off some of this file after we're done reversing the dump. So we'll save it, and then we'll xxd reverse flag.dump into flag.png. Okay, so this should be the whole file. We just need to clip off why are there, yeah, that's a good question. Why are there so many leading zeros? All right, let's go back in with our nano. Huh. Yeah, the funny thing is, I think something went wrong. Okay, right-click the packet and follow the TCP stream. Show data as drop-down from ASCII to RAW. Click Save As. You can save the raw data to your computer. Note, you may need to manually trim the HTTP headers using a hex editor if the file doesn't open correctly. Yeah, so I think this is what we're encountering right now. Okay, so maybe instead of the hex dump, we'll just get the... raw bytes. Or actually, these are not exactly raw bytes, but these are not raw bytes. These are hex bytes. So let's just copy this. Flag.bytes. And I think we might be able to do some, what is it called? CyberChef. We might be able to CyberChef this. Anyways, we got ads running on Twitch right now, so while the ads run on Twitch, we'll put on the birds. Here's a snowy day. Those are some noisy birds. We'll be back in about 30 seconds. Dang, these guys are noisy. Okay. Alright, so we've got the raw bytes over here. We might be able to paste this into something like CyberChef. cyberchef.io. Okay, and then we'll just from hex. Okay, so from hex over here, we just need to clip off everything we don't need. So all these 2Ds, and then we get rid of... I think we're looking for everything up until the magic bytes. So the magic bytes are... PNG magic bytes. So 8.9. So we just need to clip it off at 8.9. Whoops. There it is. There it is. Okay, so we should... right here. Okay. So this is the... these are the beginning of the magic bytes. We'll just move down to the bottom. And we'll identify this part over here. So just these dashes, and we'll remove these. So the dashes are... let's move down to the bottom. So everything from all these 2Ds over here. So 2Ds, remove all. Okay, and now you want to look for the /r/n. /r/n. I think we got all of it. So is the file supposed to end with a 0A, or is it not supposed to end with a new line? So do we get rid of the new line? Okay, we'll delete the new line. And then we'll save out this out. Well, I think we might be able to save this, right? Or save this. Save output to file. Save raw output to clipboard. Replace input with output. Yeah, okay. So we got the new line. Save output to file. We'll call it flag.png. And we downloaded it. Okay. Now we'll move it into our folder, and hopefully we can read it. We'll remove whatever we have here first, and then okay, now it is registering as a PNG file. This is good. We just need to read it. XTG open. Okay, we got it. Extracting flag like a boss. So, I mean, we could manually try to read this, but what we really want to do is we want to use a tool to extract the text. So let's give it a try with like Google image search. Google reverse image search. So we can go into image mode and then upload our image. CyberChef. Can CyberChef do OCR? I know Google can do it. Okay, so we'll do translation from English to English. So can we extract this text? I've done it before. CatQuest, hello, nice to see you here. Network System Security Engineer, hello, nice to see you here, CatQuest. Okay. So copy text. We can select this link over here, copy text, and hopefully this is the correct flag. Let's check. Flag extracting flags like a boss. Okay, and we'll try submitting this as the flag. Wrong flag. Okay, so it messed up some of the characters. So let's figure out where it messed up. So we'll just put this over here, and then we'll compare the two. Flag extracting flags like boss. Oh, okay. I see where it screwed up. So this is interpreted as an O, but it's actually supposed to be a 0. Okay, it was in the tab before, was it? Select it, Windows Server on VM 80 attacks. Yeah, we're gonna be doing a module from TryHackMe. This one over here, Introduction to Active Directory Breaching. It looks like a pretty good one. We've got a multi-server scenario, and we're gonna get to use some of our AD scanning tools to run it against this AD network. So that's gonna be in about an hour. So if you come back in about an hour, we should be starting this. Okay, so let's try submitting this new flag. And that's the right flag. Awesome. Okay, so we'll just do our write-up really quickly, and then we can move on to the next part. So we'll call this write-up Export Objects. Have you solved pivoting challenges? We've done pivoting challenges in the past. It's not something we cover very often on the channel. But if you're talking about pivoting using stuff like SSH tunneling or tools like SS Shuttle and what's the really popular one? What's that really popular pivoting tool? I kind of forget. Oh no. Does anybody know? Chisel used to be very popular, but Chisel, people like to use, oh gosh, what is it called? Okay, I would like to learn playbook attaches with Ansible. Oh, Ansible. I mean, I've only ever touched Ansible a couple of times. So the URL of the challenge, the concept to solve the challenge, and the method of solving the challenge. So the URL we're dealing with here is this one for this challenge. The concept in this one is extracting file contents from an HTTP packet. Okay, and then we need to talk about how we solve the challenge. Ligolo, yeah, that's the tool. Ligolo and Ligolo NG. Artifact, yes, that's it. Okay, April says, wasn't Ansible the GUI for Meta from the guys that went on to develop Cobalt Strike? Or am I misremembering? I mean, Ansible, I know it's some sort of like automation software, or like what is it called? It was like something you use for. He's thinking of Armitage. Oh, Armitage, yeah, Cobalt Strike and Armitage and Metasploit. So the method to solve here is to find the HTTP packet that has the flag.png file. Then right-click and select follow, what was it, TLS stream? Follow TCP stream, right? Okay, in the viewer, select, was it view raw? Or like show raw, right? This one here, show as raw. Okay, highlight, everything in the server's first response. Then paste it into CyberChef. Okay, in CyberChef, Victor86 says 30 years since the movie The Matrix. 30 years since the movie The Matrix. That makes some people feel very, very old, huh? It's a configuration management software. Oh, okay. Okay, so in CyberChef, use the recipe from hex. In the input, clip off all the beginning hexes until you reach the magic bytes for the PNG file. The magic bytes for the PNG file are 89, well, these ones. Okay, and then clip off all of the ending footer data starting from dash 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 Okay, sniffing packets is good to learn too. Man-in-the-middle attacks. Yeah, man-in-the-middle attacks are pretty good for doing Active Directory stuff. Usually use, what is it called? What is the name of that tool that everybody uses for man-in-the-middle stuff? It's a tool called, it's not called Interpreter, it's called something, no, it was the Responder, right. Second in mind, you're correct. Or that's the tool that I was thinking of, rather. Yeah, Responder, I mean, it's a really old tool. DNS poisoning, yeah. DNS poisoning and LLMNR poisoning, I think. Okay, so let's look at the CyberChef. So the last byte should be 0D. Okay, save the file. In the output window as a, well, just to save it as flag.png. The flag is in the image. Done. Okay, commit those changes. All right. Let's go ahead and move into the educational portion of the stream. So we got 60 minutes. This is HackerFrogs AfterSchool. So this is HackerFrogs AfterSchool Forensics session number 6. So today we're going to be learning about disk image forensics with the, oh, what is it called again? Autopsy, with the Autopsy program. So the first room we're going to be taking a look at is this TryHackMe link, Advent of Cyber 2023. So even though this is a Christmas themed event, it's got some good stuff for digital forensics. Let's talk about it. Okay. This is HackerFrogs AfterSchool, Disk Image Forensics Part 2. Topic number 3 is here. Topic number 4 is on deck. and we're ready to go. So, welcome to HackerFrogs AfterSchool. This workshop is the 5th class for digital forensics. In the last workshop, we learned about the following digital forensics concepts. We learned about the SleuthKit software. SleuthKit is a popular program used in digital disk forensics, and it includes several useful commands for interacting with disk image files, including mmlms, which is a command that displays the media management of disk image files in a list format. So this is very good for figuring out if there are multiple partitions in a particular disk image. The fstat command, which is used to display statistics associated with the file system. So normally we use this command to figure out what kind of file system is being used in a particular partition, for example, ext4 or something else. Can you adjust the screen, please? What do you mean by adjust the screen? Free Montoya. Hello, nice to see you here. Okay, and the fls command. So the file system ls command is used to list out files and directories within a specified file system. And the icat command. So icat, which stands for inodecat, is used to read specific files in a disk partition according to its inode number. Looks zoomed in. I mean, I try to zoom in as much as I can. If you find that this stuff is like too big or too small, let me know. Okay, so this workshop, we're going to be taking a look at some different topics. Digital disk forensics with Autopsy. So Autopsy is the GUI version of the SleuthKit software. We're going to be solving a challenge from Advent of Cyber 2023, and then we're going to be doing a separate room called Disk Analysis in Autopsy as a challenge. So the first thing that we're going to do is we're going to introduce this Autopsy forensic software. So Autopsy is the GUI implementation of the SleuthKit, and it allows users to view the contents of disk image files in a much more intuitive manner. So this looks a lot more like a file tree, which most people are more familiar with dealing with. So before we go on, we're just going to start up the room that's associated with this challenge. Just a second. Let's get that link. You have to find files in logical disks. Find files in logical disks. Okay, so this room over here, this was part of a Christmas event, but we're going to be using it to learn more about Autopsy. So which day are we looking at? We're looking at task number 30. So in the TryHackMe room, what I want you to do is I want you to join the room, and then I want you to scroll down all the way until task number 30 in the room. So this is mobile analysis. You are on the naughty list, McReady. So open up the tab, and then start the machine. So when you start this machine, it's going to open up a desktop that you can interact with. So while this machine starts up, we can talk a little bit more about Autopsy, and then we can jump right in. So let's see. We take a look at Autopsy with an easy challenge from the TryHackMe Advent of 2023 event. So like I said, what you want to do is you want to go to the TryHackMe room and then navigate down to task number 30 and then start up the machine. So there are a few different views in the Autopsy UI that we need to pay attention to. So when we open up the Autopsy program, there's going to be 3 sections. So this red section here, this green section over here, and this blue section down here. So there are 3 major views to pay attention to in Autopsy. So the tree viewer is red. So this part over here is the tree view. The results viewer is this green portion over here. And below the results viewer is the contents viewer, which is in blue over here. So The tree viewer is the most general view and allows us to browse the disk image contents by the directory tree or by sorting categories created by Autopsy plugins. So this is where we look for specific files in the disk image. The results viewer is in the upper right portion of the screen. And this is where we look after we've selected an item from the tree viewer, and it provides more information in a list. Okay, it's just for managing logical space disks. Autopsy. I mean, as far as I know, Autopsy is the GUI interface, or it's the GUI version of the SleuthKit software. So let's see. The contents viewer is where we can inspect individual files. And let's see. So we're going to be, let's see if we've loaded up the room yet. Okay, we just need to wait for a few seconds more. So after this machine is finished loading up, we can put the virtual machine in its own browser tab. So this machine here, it should be logging us in just a second or two. Okay, and after it's done, we can go to the middle of the screen here, and then down to the bottom. So the middle of the screen, and then down to the bottom, there's a button here labeled View in Full Screen. Try my patience, HackerFrogs, yeah. So here, there's a button labeled View in Full Screen, and then you click on it, and that's going to put this VM that we've started up in full screen, or in its own browser tab. This is what we want because otherwise we're going to have to look at a very cramped view, which is definitely not what we want. So because this is a TryHackMe Windows machine, it means that they don't provision very much resources for these Windows machines. So the machine is actually very slow. What we want to do is we want to click on the Autopsy icon down on the desktop. So it's over on your left and then down at the bottom. So here's the Autopsy desktop icon. Double click it. Yeah, Windows Server VMs on TryHackMe are usually quite laggy and unresponsive. And it's actually going to take a while for Autopsy to load up. Windows is less efficient than Linux. I mean, Windows definitely takes up a lot more resources than Linux on average, for sure. So we're gonna have to... I can't even tell if it's loading up because it's so unresponsive. I guess what we should have done is we should have used this this shortcut right over here. Actually, let's just click on this. Okay, so it didn't even register my double click. The Schrodinger state of THM boxes, yup. Okay, so we just need to wait for the thing to load up. Come on, box, you can do it. So the other thing we can do is we can go back into, there we go, it's loading up. So we can go into the TryHackMe room, and then we can exit the split view. So down here at the bottom. Okay, so in this room we need to learn about the procedures for collecting digital evidence, the challenges with modern smartphones, using Autopsy digital forensics with an actual Android image. So I think they'll tell us what we're supposed to be doing down at the bottom over here. Okay, so You know what? We should be able to find the image in question over here. So we want to open a recent case. So we can create our things. Okay, so Tracy McReady, this is the case we want to open here. So click on it and then click open. So slow, no good resources to launch the VM. When are you dropping the eBPF video? I'm not too sure when I'm going to be getting around to that, Sandy. But nice to see you here. Security of database files. Oh, all right. Probably Tuesday. Probably Tuesday. So I think the other thing we could, well, we're gonna have to play around with the interface after the file loads up. The thing about Autopsy is that Autopsy is kind of a heavy program in and of itself, which definitely doesn't help as far as trying to load up these files is concerned. Okay, I think we're done. Okay. All right, so we've got our file tree over here on the left-hand side, and then we've got the oh, what were these views called? So there's the tree view, which is on the left. CTF OK firewall. Not too sure about that. So the tree viewer is on the left, and then the on the upper right is the results viewer, and then the content viewer on the lower left. So this is it over here. So from here in the tree view, we could select specific files to look at. For example, if we wanted to take a look at files by file type, we could look at the MIME extent. Well, we could look at the extensions. And for example, if we wanted to take a look at an image file, we could click on images here. And the images, we could select a specific image in this other view. Hold on. So for example, one of these PNG files. And the PNG file is going to load up in the lower view, the content viewer. Or the results viewer? Hold on. I think I can... Can I adjust the zoom on this? Okay, select one of these. Ah, okay. And then we see the actual image file over here. So down at the bottom. But of course we can't see it very well. Let's see if we can zoom in. Yeah, we can zoom in. Okay, but we can't actually... We don't see very much because this stuff is kind of cramped. If we scroll down, let's see if we can find another... Let's see. Okay, so here's a much nicer looking image file to look at. So we selected this file by selecting the types of files we wanted in the tree viewer over here, and then we selected from the image files in the content viewer up here, and then the results viewer is where we actually see the contents of the files that they select. Okay, so what we're going to do is we're going to try to achieve, we're going to answer certain questions about this disk image. Let's go back to TryHackMe and down to the bottom. So the first question here, it says one of the photos contains a flag. What is it? And I guess, oh, I've already got my answers here. Hold on, let me reset the room. so that the answers aren't here anymore. Just a second. Okay, reset progress. And then we'll go back down to task number 30. Okay, so the first question here is one of the photos contains a flag. One of the photos contains a flag. What is it? So if we go into autopsy here, and we're already looking at the images, which is good. So we can search the different files inside of the disk image by, according to different categories. For example, images or videos or audio files, archive files and databases, and maybe other documents as well. So we got HTML documents, Office documents, plain text files. And what we're looking for is we're looking for these images over here. So in the file tree viewer, we can click on file views, file types, by extension, and then we can click on images. So it says one of the images contains a flag. One of the images contains a flag. So I mean, I would guess that if we wanted to look at the images that might contain a flag, we would what was the word? We would organize them by the size. So over here, there's a bunch of different columns that we can filter by. So modified time, name, created time. We're just going to click on the size one, and we're going to scroll down to the largest files. So we got map 1, okay, map 2, and then scroll up. We've got board 2. Here we go. Okay, so this is the file we're looking for. So if we wanted to extract this, we can actually extract it by right-clicking on it, and then we can extract the file. So right-click on the file you want to extract. Extract to... Let's just put it on the desktop. So we'll just go back up to the desktop, and then click on Save. Okay, file extracted, great. We'll just double-click on the extracted file, and then we can look at the file inside of a dedicated image viewing program, which is MS Paint. Great. Okay, so this is the answer for the first question here. So it's THM digital _ forensics. So nice and easy, so we can just copy it down by hand. THM squiggly brackets digital _ forensics. Okay, and then submit this as the flag. Helicopter text files, joking, of course. Volume sound is high. Oh, okay. Let me see if I can reduce the volume a bit. Okay, and the next question that we're being asked to answer is, what name does Tracy use to save Detective Frosto's phone number? So what we're dealing with here is we're dealing with the contacts in the Android system, or the Android file system. Okay, is it close to plain text files? Okay, I haven't heard that one before, says OS. Okay, so what name does Tracy use to save Detective Frosto's phone number? We can go back into the machine. We're gonna close the text viewer, and we're gonna open up Autopsy again. Okay, so in Autopsy, we can go down to data artifacts. So data artifacts, we've got contacts in here because the question was asking us about the contact names. So click on contacts, and then we see some different contacts on this Android phone. Tatted Juan, hello, nice to see you here. I hope I'm not distracting you. Definitely don't definitely get to your destination safely, Tatted Juan. Okay, so we've got our contacts. We're just going to click on each of them. Actually, we've got a name up here. We might be able to do a search for Detective Frosto, because that's what we're looking for. Detective Frosto. So one thing we need to understand is to solve this question is that this is part of a storyline where Detective Frosto is this guy up here. Where is it? Under Task 1. Yeah. So Detective Frosto is this guy over here. He's the snowman detective. So we go back in here. We've got a name, and we need to guess that from the context clues that this is the name for Detective Frosto, because it's Detective Carrot Nose in the contacts list. So I don't think there's anything else in here. Okay, so we just need to submit this name. So the good thing about the plugins for Autopsy is that they're able to group up the data artifacts by category, such as contacts and messages, metadata, and then they're able to also group up the files inside the file system by file type, like images and video and audio, etc. So if we go back down to the bottom, we can answer this question in task number 30. Okay, what name does Tracy use to save Detective Frosto's phone number? This is Detective Carrot Nose. Click on check. Okay. And the last question here is, one SMS exchange with Van Sprinkles contained a password. What is it? Okay, so here we're going to be investigating the messages inside of the Android phone disk image. So we're just going to go back up to here, and in the file tree, we're going to navigate down to data artifacts. In data artifacts, they've got messages down here. So this is a list of all the messages on the phone. And I think we can actually see the content of the messages if we start dragging these columns over. Okay, so we see the conversation over here. So the conversation goes, "Hi, what's up? I was going to write you. Hi, did you hear the news? Our company is getting acquired. Yeah, I just heard. I'm not sure how to feel about it. I've been here for a few years now, and I've really come to..." What? Can we select this? Hold on. I think we can get more text. Okay. It's just... It's a really long message. I've been here for a few years now and I've come to love the company culture and my colleagues, blah, blah, blah. And let's see. Yeah, it's a big concern. What do we do now? I don't know. I guess we have to wait and see what happens, but I'm not optimistic. It is a horror story written by Stephen King. That's true. That's true too. Actually, I'm going to do everything within my power to stop this from happening. What do you mean? I won't let them have peace. What? It seems like a conspiratorial thing. I don't know what to say. Maybe you're right, but they are good people. They will be making a big mistake if they proceed and demote me. Demote me. I don't know what to say. There's a password I want you to save for later, just in case. Make sure you keep it somewhere secure. Password. Okay, I will save it for you. So they've got the password over here. Can I double click this? And actually, wait. If we go over to this view, then we can actually see the text in full. So here's the text. Can we highlight it? Okay, highlight, Control C, copy. Yes, it works. Okay, that's great. Wild Radio Root says, I'm finally home from the dentist. All is well. Awesome, awesome. Hope you had a good dentist visit. Hope your mouth isn't feeling too bad. All right, so let's answer the question. So one SMS message exchanged with Van Sprinkles contains a password. What is it? So we paste in the password, click on check. Okay, so that's all we've got. That's all we have to do for this room. But before we go, so the basic workflow when we're working within Autopsy is to look for the type of files that we're looking for in the tree view over here. Okay, and we've got we have videos. That's kind of weird. Let's click on videos. So we got some MP4 files. It looks like most of these have been deleted though. I wonder if we can recover them. Also, hope the wallet is feeling okay-ish. Yeah, I hope you don't have to pay a lot of money for listening to the live stream helped. Okay. So I wonder if we can extract these files. So we got a couple of MP4 files. So I'm just going to click on one of them. We'll try extracting it. Right-click, extract file, and we'll see if this works. File extracted, okay. And then we'll see if we can open it up. Of course, this is really slow. Okay, choose the initial settings for Windows Media Player. How about recommended settings? Sure. Finish. Importing media. I wish I could just play the video. Okay, what do we got? It looks like a blank screen. Looks like no luck. Oh, I think this is supposed to be some sort of... Yeah, okay. Oh, we've got the video. I don't know if you saw that. It's some very exciting stuff. Okay, so I think we're done here. There's another autopsy room that we're going to be taking a look at as well. So we're just going to terminate the machine. So down here, terminate the machine, and then we'll move on to the next room. Okay, so Nitro Based, hello, nice to see you here. So we're just going to terminate the machine. So inspecting photos. The first question from the task requires us to look at photo files. We can go to data sources, file views by extension. So data sources, file views, file types by extension images. We also need to check the contacts on the image. We can go over to data artifacts and then contacts, and this will let us see all the contacts on the phone. And then the SMS messages. So we go over to data artifacts, communication accounts messages. Okay, and the next room we're going to be taking a look at is the autopsy room over at TryHackMe as well. I'm pretty sure we can, yeah, so this is the link. How can I find this PDF? So this PDF here, let's see, let me get that for you. So if you want to look at this PDF specifically, it's here. Which session is this? Okay, here's the link. Okay, so where was the link for... Okay, so this is the link that we're going to be doing for the next TryHackMe room. Let me just grab that. We'll paste it in. Okay, this room is called Disk Analysis and Autopsy, and let me go ahead and reset my progress on this room as well. Oh, there's no progress. Okay, that's good, because there's a bunch of questions we're going to be answering on this room as well. So what I want you to do is I want you to click on the Start Machine button in task number 1. It's going to take a couple of minutes to load up, and it's just as slow. It's probably going to be just as slow as the other machine, so I hope we can all be patient while we deal with these hardware limitations, virtual as they might be. So like before, we're going to be answering a bunch of questions about the disk image by using Autopsy to browse around. So in this case, we're going to be figuring out the MD5 hash of the image. We're going to try to figure out the computer account name. We're going to list all the user accounts, apparently, and a bunch of other stuff. So if you want to know exactly how to finish the room, I think I've got a write-up for this over here. Oh no, I've only got the method of solving this for the first challenge. Okay, that's fine. Let's see if we can solve this afterwards. Alright, so we've got a Windows machine that we need to log into that has the Autopsy program installed on it. We're just going to move over to the center of the screen, then down to the bottom again, and we're going to click on the View in Full Screen button here. Any roads for maldev? I mean, if you want to do malware development, I'd say what you want to do is you want to take a look at the education links over here, and you want to do some courses on reverse engineering, because to understand malware development, you need to understand like low-level programming, stuff like C and stuff like assembly. So x86 assembly is a pretty good starting point. There's a very good course for reverse engineering and as well as binary exploitation over at pwn.college over here. And after you've got a good grasp on binary exploitation, reverse engineering, you might want to take a look at Maldev Academy. It's not free. I haven't been able to find any malware development resources that are free, but this one's very highly recommended. MaldevAcademy.com. I'm not too sure how much the course costs. Let's see, offerings. Malware development course. Okay, so what's the pricing on this thing? So it's a $500 course. Anyways, okay, so we've got our machine up and running, and we're going to need to start up Autopsy again. So double click on that Autopsy icon and wait for the thing to load up. Okay, just wait for the thing to actually happen. I'm pretty sure there's also an Autopsy case that we need to load up after we open up the program. So as far as where to get Autopsy for your own computer, and Kiwi, I can't read that. I can't read that. If you could please type in English, that would be great. Okay, what was I looking for? I was looking for Autopsy. Autopsy Forensics Software. That's strange that the link is not one of the first ones. Okay, so if you want to get Autopsy for yourself, you can download it from over here. Okay, so Cypher says, I never want to be a student or take any paid education again. I never want to be a student or take any paid education again. Well, I mean, there's nothing wrong with being a student. If you don't want to pay like large amounts of tuition to go to school, that's a different thing. Okay, sorry. Let's close up our Wireshark. Okay, so what we want to do is we want to open a case inside of Autopsy here. The windows are a bit too big. Let me see if I can reduce the size of this. So zoom. Yeah, make it a little bit smaller. All right, so open case. And I think we want to take a look at the case files over here. That's on the desktop. So we're just going to navigate up to the top, to the desktop, and then click on case files, and then TryHackMe.aut. Click open. It's going to take a while to open, just a second. Okay. Opening text index. For large cases, this may take several minutes. Yeah, like I said, Autopsy is kind of like a heavy program in general, so it's not super responsive. So after it opens up, we'll full screen this so that we get a little bit more room. Okay, one of the images associated with this case are missing. Would you like to search for it now? Previously, the image was located at Administrator's Desktop TryHackMe Hassan2.eo1. Okay, so we want to search for it, sure. Click yes. And I'm pretty sure it's going to be in the same folder. So we're just going to go up to the top and click on case files. And here it is, Hassan2.eo1. So click on it, click open, and then select image. Cool your machine with liquid helium to make it run faster. I don't know if cooling my machine with liquid helium would help the TryHackMe machines run faster. It might be interesting. Okay, so we're just going to full screen this. So they want us to do specific things in this particular disk image to answer questions. So the first one is, what is the MD5 hash of the E01 image? So MD5 hash. So for these particular disk images so we can click on the disk image here. So there's a disk, and I'm pretty sure we can find this in the metadata. So we can click on the disk image itself, which is up at the top, data sources, Hassan2.eo1, and we can click on the file metadata after we click on the file over here, and we see a couple of different hashes. There's an MD5 hash, there's a SHA-1 hash, and a SHA-256. Well, there's no SHA-256 hash, but they're looking for the MD5, I'm pretty sure. Okay, so let's grab, they want MD5, right? MD5, yeah, okay. So let's go ahead and highlight this, and then copy, then go back, paste this in, check. Why is it saying that I solved a room? I didn't solve the room. Hold on. Okay. Let's continue. and it will exit split view here. All right, so we just figured out the MD5 hash of the image. The next thing is to figure out the computer account name. So how do we figure out the computer account name for this thing? Stay paranoid out there. Hello, nice to see you here. What is up? Okay, we'll go back to, why do we need to reload this? So what we need to do now is we need to figure out the computer name for this image. What is the computer account name? Okay, so we can probably figure this out by clicking on, what do we have? Extracted content, accounts, interesting items, XF metadata. This might be in the metadata of the disk images as well. So let's see. So after we clicked on this, here, we have a bunch of different volumes here. So inside of the Hassan 2 disk image, we've got 6 different volumes which have different file systems. I think what we're looking for is the system volume information. So we see, so let's see, volume 2 and volume 3 both have system volume information, which might have the computer name inside. Okay, I don't see very much here. How about the other one? System volume information. And I think we've got an ad running coming up on Twitch fairly soon. So we'll just wait for that to start, and then we can take a little break, and then we'll come back to this. NitroBase says, would you advise me to write down what I study in a notebook? I mean, definitely keep track of it somehow. Okay, the ads have started on Twitch, so we'll put on the birds. Which birds are we going to do? How about... How about these birds? Okay, we'll be back in about 50 seconds. Just need to take a little water break. If you wonder why birds are always looking around, it's because birds have to be constantly on the lookout for other animals that want to eat them. So they need to be constantly looking around to make sure that there's nothing sneaking up on them. Tad1 says, in cybersecurity, there's no such thing as not being a student. You're going to continuously learn all the time. I mean, I'm pretty sure the person who was talking about not wanting to be a student was talking about not wanting to be a student who goes to university and pays a bunch of money. Not talking about being a student in general. Anyways, shouldn't it be a frog watch? Shouldn't it be a frog watch? I mean, if I had frogs around here, I might make some videos out of them as well, but I don't think we do. So I can't. Anyways, I'm gonna try looking this up. So TryHackMe autopsy? No, not TryHackMe autopsy, just autopsy. So this is a Windows disk image we're looking at. So where would we look if we wanted to figure out the name of the computer name? If you want to sneak up on birds, go head on, then they sense you from behind, but they don't really see ahead because eyes on sides. Maybe. Okay, so let's see. Autopsy. Windows disk image. Computer name. Computer name lookup. Registry files? Yeah, it might be in the registry files. Okay, so what does it say here? To look up the computer name of the Windows disk image in Autopsy, expand the Results tab on the left-hand navigation tree, go to Extracted Content, click on the Operating System Information. So Extracted Content, Operating System Information. Let's give that a try. So let's see. Extracted Content, Operating System Information. Okay, it's here. So it's just down here. And let's see, the name of the system is desktop something something. Desktop this thing. So I think we can. So this doesn't seem to appear in the metadata over here, in the whatever, the detail view. Can we copy this? No, it just took a while to... Okay, so we can copy down here and then go over to TryHackMe, paste in the computer account name, check. Why do you keep on telling me I finished the room when I answer one question? This is frustrating. Gabriel says, predators have forward-facing eyes, prey have eyes on the side. That makes a lot of sense. Okay, so let's go down. The next question is list all user accounts in alphabetical order. So user accounts. Okay, let's do it. So man. I'm pretty sure you can get the user accounts from the extracted information as well. Come on, load up. Okay, so under results, extracted content, we're going to click on, where is it? Operating system user accounts. So it's just underneath operating system information. And we see all of the different accounts over here. But the thing is that they're not in alphabetical order. Maybe I can get everything here and then start doing some Linux foo. So extract files. Can we select only the username somehow? Sort? I mean, sorting it doesn't really... I don't think it helps too much. Can we copy this? I'm going to try copying this over to, like, a text editor. Nope, that didn't copy. Because doing this manually is going to be a big pain in the butt. So, I mean, we could click on each one of these and then copy them one by one. I mean, I guess that's what we're going to have to do. And I'm pretty sure they don't want the system, like the system accounts. Oh, whoa. Maybe not so much of that. Anyways. Alright, Joshua. So what we need to do is we just need to gather all of these user accounts, and then maybe we'll use... Maybe we will use AI to sort this out for us. Okay, all these names. Okay, so how many names is that? So that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So there should be 8 names that are not the administrator or anybody else. Wait, is there something wrong with the sound quality? So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 names here. So we'll copy this and then we'll give it to the AI. Okay, nothing wrong with the sound quality. Great, great. All right, so take this list and turn it into a single line. Alphabetically sorted. And with commas. Separating each one. Okay, and then paste in the list. Okay, let's see if this works. Copy it, go back to TryHackMe. Okay, it looks like they didn't want spaces, so we'll just remove the spaces. And submit. Stop telling me I completed the room each time I answer a question. Is Perplexity AI good? I mean, I'm using Perplexity AI because I've got a free subscription for a year, so I'm giving it a try. So Perplexity AI is supposed to use a bunch of different AI models and choose the best one. I found it pretty good so far. I don't have too many complaints. If anybody has any experience with Perplexity, let us know. Okay, so the next question is what? Who was the last user to log into the computer? The last user to log into the computer. Okay, so we need to take a look at the event logs, maybe? Or we need to take a look at... Let's go back in. You have the plan for free pro? There was like a limited promotion. I think it was like at the end of last year. I think I've been using it. Yeah, I think I've been using it for about 6 months now. It's not bad. Can we make this bigger? Not here. All right, so let's go down to... Okay. I mean, we could try to figure this out ourselves because we've got all of the names. So date accessed. Oh, you know what? We might be able to just sort this by date accessed to figure out who is the last user to log in, right? So we'll just play around with the columns over here. So date accessed, we'll sort this. And we're looking for who is the last user to log into the computer. So the last user to log into the computer is Siva Priya. Because that's the last one on the list. So we'll copy this, paste it in. Oh, wow. Okay, let's... You know what? I don't know what's wrong with this room, or what's wrong with the TryHackMe system right now. Okay, what's the next question? So the next question is... What is the IP address of the computer? The IP address of the computer. Okay, so let's try to figure it out. I'm pretty sure we can get the IP address from... like some sort of registry file. So Windows, Autopsy Windows, disk image, IP address lookup. 127.1, well, .0.0.1. Okay, to find the IP address within the Windows disk image, search the Windows registry, network monitoring logs, or web browser artifacts. So I guess we could try extracting from the Windows registry. So registry location, see Windows System 32 config, and then look for set control services TCP/IP parameters interfaces. Huh. Okay. Or check network monitoring tools. If the system has network auditing tools installed, they frequently log IP addresses. So look for look at LAN or Wireshark. Check the installed programs folders. Okay, so we can probably take a look at the installed programs on the disk image, right? So back here, let's see. Installed programs. So there's only 41 of them, so we can quickly look through the list. Okay, let's look through these. So Python. Let's see. Oh, we've got look at LAN here. So look at LAN, they said that network monitoring programs like look at LAN might have the IP address logged. So let's see. Look at LAN or Wireshark, check the installed program folders, look for the INI log files that store device connection history. So where do we find the associated files? Darn it. Why is the connection so bad? Come on. Okay, so can we right click on this and... So where are these look at LAN and INI files going to be stored? We know that the thing is installed. Maybe we can take a look at the data sources. So maybe look for the program files in the tree. So program files here. And we're looking for the look at LAN program. So program files x86. Look at LAN is over here. I found it. Okay. So click on that. And we're looking for an INI file. Let's just check which one. So look at LAN. INI file IP address. Okay, define the computer's IP address within look at LAN configuration file. So it's going to be lookatlan.ini. Lookatlan.ini. Okay. I don't see it. Maybe we can just check all the INI files. Okay, here we go. So this is, what is it? What is the name of this file? This is the irunin.ini, and we've got an IP address here. So up at the top, we've got LAN IP, and I'm just going to highlight this. And this is the IP address we found. We'll try submitting this as the answer. Check. All right. So if you want to test out your autopsy skills, you can go over to this room and you can complete all the other questions. So this one over here. But that was our look at autopsy. So let's review the digital forensics concepts we learned in this workshop. We've run out of time, but yeah, I'm sure you get the gist. There's a bunch of different. Autopsy is it's a pretty good tool for looking through disk images in a systematic way. So Autopsy Forensic Software. Autopsy is the GUI implementation of the Sleuth Kit, which is the CLI version, the CLI suite of tools that can be used for digital disk image forensics. It allows users to view the contents of disk image files in a much more intuitive manner. There are a bunch of views in the Autopsy UI, and there are three major views we need to pay attention to. So there is the tree viewer, the results viewer, so the tree viewer here, the results viewer here, and the contents viewer over here. So we demonstrated how to find information in each one of those views. So the tree viewer is the most general view. We select from here, then we move on to the results viewer here, and then afterwards we can look at the contents viewer down below. So what's next? In the next HackerFrogs AfterSchool Digital Forensics Workshop, we'll learn how to investigate memory forensics files with volatility. So memory forensics is kind of a niche field, but it's very, very interesting because using memory forensics, you can pull out all the information that was working in the computer's memory at a particular time. So it's a memory snapshot. So all the information that was loaded into the memory, we can investigate it using software like volatility. And that's what we're going to be covering next time. All right, so the next lesson is going to be on Monday of next week. So we do, sorry, not Monday, Wednesday. So we do a stream on Wednesday and on Friday. Let's move on into the last topic for today's stream. Okay, so for the last topic for today's stream, what we're going to do is we're going to investigate this room over here from TryHackMe. It's called Introduction to Active Directory Breaching. So this covers how to hack the most common type of system that you'll find for Windows, networked Windows machines, and it's called Active Directory. So before we get going, and thank you very much for Sherlock Lol for following on Twitch, thank you. Before we get going, let me go ahead and close out all these other windows that we're not using, because when there are too many windows open, it makes me very sad. Okay, so after you've arrived at this room, what you want to do is you want to join the room, and we've got a network map over here. So we've got a web server that's running Linux, and then we've got a bunch of Windows machines. So it's the Windows machines over here that are all... Oh, interesting. Oh, the web server is serving a bunch of different websites. Okay, so we've got a web server over here, which is serving up three websites: git.thm.lock, ci.thm.lock, and printer.thm.lock. So I'm guessing what we need to do in this particular exercise is we need to somehow compromise the web server, and from the web server we need to pivot into the Active Directory network. So there's rootdc.thm.lock, there's wrk, and there's server 1. So let's go ahead and get into it. SysOS says Active Directory because Open LDAP ripoff did not score well with the target audience. Or focus group. I mean, I've never dealt with Open LDAP before, so I'm not really too sure about that. Okay, so let's take a look at what we're doing in this network here. So in an Active Directory AD environment, everything starts with the first set of valid credentials. Without them, you can't enumerate, you can't move laterally, and you certainly can't elevate privileges. The process of obtaining those initial credentials is what we call breaching. In this room, we'll expose several common techniques attackers use to gain that initial foothold. Starting with nothing more than network access, we will work through a natural attack progression from reconnaissance and credential hunting through to password spraying and authentication coercion to obtain valid AD credentials. So what are we learning today? In this room, you will learn the principle and methodology for breaching AD environments, enumerating valid usernames with curb root and performing password spraying attacks, an introduction to the world of authentication coercion and coercion-based breaches, and common mitigations to protect against these breaching techniques. So for a prerequisite, before starting this room, you should be familiar with the following: basic understandings of Windows operating system, ability to use command line tools in PowerShell or CMD, concepts covered in Active Directory Basics, Windows Fundamentals, and Introduction to AD Authentication. So, start the network. Before moving on to the next task, click on the green Start button under the network diagram. Give the network enough time to launch, and then you can connect to the network in two ways. So I guess we could use the web-based attack box. It's just that we're very likely to spend more than an hour working on this module, which means it's not really very well suited to this. Have you sold your soul to $optional? That's the last requirement, of course. Okay, so we're going to go up to the top of the room, and we're going to locate this green button here underneath the network map. So click on Start. Afterwards, we're going to have to download the VPN profile to access the room. Okay, so click on Download VPN configuration file for this network, so click on that. Okay, are you using OpenVPN? If so, you'll need a specific VPN profile to access the network. Download it here and follow the instructions or manage your connection via the settings page. Okay, the file will be saved as this. Okay, sure. Let's click on Download. Okay, so that downloads the VPN key to our computer. And afterwards, let's see, I've got a tab just for this. Okay, we're going to move into our Downloads folder. We're going to locate the key, this one over here. We're going to move into our VPN keys directory. So move this into VPN keys. So I keep all of my VPN keys in a specific directory here. And we're going to need to use OpenVPN to access the network. Where is that thing? Darn it, what was the thing called again? Okay, the Shy-Hat AD breach. Okay. Here it is. Okay, so just run OpenVPN with sudo with the VPN key. So the way we'll know that we're connected, well, I mean, we don't actually know that we're connected to the network, but if you're connected to a network via OpenVPN, you'll usually see a ton interface over here. And if it's the first interface, it's usually going to be ton 0. If you have an IP address on the network, that probably means you're connected. But what else well, I mean, the other thing we could do is we could try to ping out to the web server over here. So 192.168.1271 and see if it actually pings, well, if it actually responds. So let's give it a try. Ping 1271. Okay, we're receiving pings back from the IP address of the web server, which means we're connected. Okay, so let us continue. Use an OpenVPN client to connect. We just did that. DNS configuration. Before we begin, we have to ensure our attacker machine can resolve the host names used in this lab. The network diagram above shows the environment we'll be working with, so it's... Okay, so we've got a bunch of different domain names that we need to resolve. Okay, so this is how you would set it up. So what we need to do is we need to start editing our etc host file on our Linux machine. So we'll go into our text editor here, this text editor here, and we're gonna sudo nano into etc host to adjust this file. We need to add some IP addresses to this so that our domains resolve correctly. So we got root dc/thm.lock, and this is the IP address over here. Okay, and then there's a few more. There is this IP address, which is for server1.thm.lock. And then this IP address, which is for work.thm.lock. And there's one more. So the last IP address is for the web server, which has 3 different domains. So copy the IP address, and we need to include 3 different domain names. So it's going to be get.htm.lock, paste it in here, then give it a space, and then ci.thm.lock, another space, and then printer.thm.lock. Okay, after this is all done, then we've got our network setup okay. We save out the file, and this should all resolve correctly. We've got ads running on Twitch, so we will take a little break. Let's put on some birds. How about this bird? Okay, we'll be back in about 60 seconds, but enjoy the music and enjoy the birds. Oh, sorry. Thank you very much for letting me know that I was muted, so as Master. Jeez. Silly me. Sometimes you mute yourself and you forget to unmute. Okay, so what were we doing? So we figured it out. Okay, I'm ready to breach AD. Check. Okay, number 2, Active Directory breaches. Let's learn about this. So what is AD breaching? Before we start hunting for credentials, let's take a step back and understand what we actually mean by breaching Active Directory. In simple terms, AD breaching is the process of obtaining an initial set of valid AD credentials when starting from scratch. So this is the very first phase of any AD attack chain. Without the first set of credentials, we can't enumerate the domain, move laterally, or escalate privileges. So we need to get our first set of credentials in order to actually interact with the Active Directory domain. So what do we have here? Breaching, enumeration, exploitation, lateral movement, internal recon, move laterally, maintain persistence, back into lateral movement, leading to persistence. Okay. So it says you need a giant red indicator for when you're muted, maybe even a siren or something. Yeah, I need to figure out if I can connect it to my overlay. Something, yeah. But I mean, if we have enough people in the chat, the people in the chat will let us know if I'm supposed to be talking. But yeah, I should probably investigate something like that. Okay, so why initial credentials matter? It might seem like a single set of low-privileged credentials wouldn't be worth much. After all, single standard domain users can't access sensitive servers or modify AD objects. However, even the most basic domain account opens the door to a significant amount of information. Once authenticated, we can query AD for users, groups, computers, group policies, and trust relationships, information that is typically hidden from unauthenticated users. In many cases, this initial enumeration reveals the misconfigurations and attack paths that lead all the way to domain admin. The hardest part is often just getting that first foothold. I was like, it's been quite a while. Is the break not over? I guess not. Anyways, the AD attack surface. A typical AD environment exposes a range of services and protocols that can be targeted during the breaching phase. These include the SMB protocol on port 445. So file shares, printers, and remote administration, often the first target for password spraying and credential testing. LDAP, which is TCP 389.636, the directory service protocol used to query and manage AD objects. Misconfigured devices often store LDAP credentials that can be recovered. HTTP, HTTPS, web-based services such as internal portals, CI/CD platforms, and device management interfaces frequently expose credentials and logs, configuration pages, or code repositories. Kerberos, TCP/UDP port 88, the domain's primary authentication protocol. Its pre-authentication mechanisms can be abused to validate whether usernames exist in the domain. And DNS, TCP/UDP port 53, used to resolve host names within the AD environment and can help us identify key infrastructure such as domain controllers and mail servers. Each of these services represent a potential avenue for obtaining the first set of credentials, whether through credential discovery, password spraying, or coercion attacks. Golden ticket, anyone? Yeah, I think they might talk about silver ticket attacks and golden ticket attacks in this module, but I'm not sure. Starting positions. In a real engagement, you will typically find yourself in one of two starting positions. Either unauthenticated in the black box scenario, or authenticated in the gray box scenario. So unauthenticated means you have network access but no valid domain credentials. This is a classic initial access scenario. You must enumerate, spray, or coerce your way into a valid account. This is the position we will simulate in this room. And there's gray box authenticated scenarios. So this is very common when you're doing network security testing. They will give you credentials for a very basic domain user, and from there you can get additional information. You already have a valid set of low privilege credentials, perhaps from an earlier engagement, phase, a phishing campaign, or an OSINT discovery. From here you can skip straight to enumeration and look for escalation paths. Regardless of the starting position, the goal remains the same. Obtain valid AD credentials that allow us to move deeper into the environment. In the following tasks, we will work through several common techniques to achieve exactly that. Okay, so let's see. What is the first phase of any AD attack chain? So it's breaching, which is what we're learning today. What service running on TCP port 80 can be abused to validate whether usernames exist in the domain? So port 88 is something you're going to encounter very commonly inside of Active Directory. This is the Kerberos protocol. Okay, and then move on to task number 3. So if you guys get lost, or if there's any questions about any of the stuff that we're doing inside of this room, let us know in the chat. I'll try to answer as best I can. I'm not an expert on Windows Active Directory, but I have experience doing security testing on in a lot of different educational scenarios. Okay, before launching any active attacks against an AD environment, we first need to build an initial picture of the target. In a real engagement, this typically starts with an open source intelligence, OSINT, collecting information about the organization and its employees from publicly available sources. The goal at this stage is simple: build a list of potential usernames that we can validate against the domain. Gathering usernames from OSINT. In practice, there are several public sources where employee names and username formats can be discovered. LinkedIn. Employee profiles often reveal full names, job titles, and reporting structures. Tools such as LinkedIn to username can automate the process of scraping employee names and generating username lists in common formats. GitHub and GitLab. Developers sometimes commit code using their corporate email address, revealing the organization's email format and individual usernames. Public data breaches. Breach databases may contain email addresses from the target domain, which directly reveal the username format. Corporate websites. About Us and Meet the Team pages frequently list employee names that can be converted into potential usernames. And job listings. Recruitment posts can reveal internal technologies, team structures, or even naming conventions. Note: in this room's lab environment, we won't be performing real OSINT. Instead, a word list of potential usernames has been provided to you. However, understanding where these lists come from in the real world is an important part of the methodology. Common username formats. Once you have a list of employee names, the next step is to generate potential usernames. Organizations typically follow a consistent naming convention for their AD accounts. The most common formats include first name, last name, first name dot last name, for example, Jane.Smith, first name, last name together, Jane Smith without any separator, first name, initial, last name, so J Smith, first name dot first letter of last name, for example, Jane.S. Okay, Martin says, how many hours have you spent learning cybersecurity to be in this IT sector? How many hours have you spent to learning cybersecurity to be in this IT sector? Is that what you're asking? How many hours have I spent studying cybersecurity? I've been studying cybersecurity for somewhere around 5 years at this point. I mean, how much? The problem with my particular scenario is that I'm trying to learn everything about cybersecurity instead of trying to focus on any one particular field, which is typically not what most people do. Most people are pretty specialized in cybersecurity. Anyways, okay, we got first name dot last initial, so J.S, just the first name, Jane, and then last name dot first name, Smith, not Jane. So the key is to identify which format the target organization uses. Often, even a single confirmed email address or username from OSINT is enough to determine the convention. From there, you can generate a full list of potential usernames from the employee names that you've gathered. Okay, so here we're talking about a very common tool that we use called KRBROOT, and we use it for username enumeration. As this is a lab, some OSINT has already been performed. Click on the Download Task Files button in the top right of this task to get the list of usernames found in the OSINT hunt. With the list of potential usernames in hand, we can validate which ones actually exist in the target domain using KRBROOT. KRBROOT exploits a behavior in Kerberos pre-authentication. When we send an authentication service request as rec for a username, the Key Distribution Center, KDC, responds differently depending on whether the account exists. Okay, April says, generalists don't seem to be trusted. I mean, it's not that they don't seem to be trusted, it's just that if you're a generalist, you might not have the depth of knowledge required to do specific tasks. So if you're a person who does only reverse engineering, or a person who only does like malware development, you can't really split your attention between a bunch of different specializations, or between a bunch of different knowledge, realms of knowledge. I forgot to put my time limit on my for this task. Let's do 2 hours and see where we're at after 2 hours. So I mean, the problem is that if you try to study everything, you end up forgetting a lot of stuff. Hex Psycho has rated the channel with 11 viewers. Hello, Hex Psycho, and welcome viewers. Let's give Hex Psycho a shout out. How do you spell that name? Thank you very much for following on Twitch, Maximus. Okay, let's copy this. Okay, we'll give you a shout out. Go. Hex Psycho, what were we getting up to on your stream? So for what we're doing on our stream right now is that we're trying to learn about AD breaching techniques. So Active Directory, trying to get our initial foothold and all that good stuff. Hello Maximus, nice to see you here. Okay, so KRBROOT, Kerberos username brute forcing. So if the username does not exist, the KDC returns in KDC error C principal unknown error. If the username does exist, the KDC requests pre-authentication, confirming that the account is valid. Hex Echo says, we were doing the Dark Zero from Hack the Box. Oh, an AD box as well. Awesome, awesome. So we can talk more about Windows Active Directory hacking. That's good. Nullsec says, I'm April, I disagree. I do agree that you forget a lot of insignificant details, but you build a lot of allegorical intelligence, which is precisely the type that a good hacker would need. I mean, the thing is that this is why it's really important when you're dealing with the highly technical topics to take a lot of good notes. So let's talk about this real quick. So when you haven't been actively doing a technical task, oh, that's not how you spell technical task, you'll eventually lose the muscle memory of doing that thing. So for example, I haven't done Windows AD hacking in a long time. So it's been, I mean, I wouldn't say it's a super long time, but it's been a few months. So I'd say it's been like 4 months. 4 months since I did a lot of Windows hacking. So if I didn't have a clear set of notes for all of the tools involved in AD hacking, I would have to waste a lot of time looking up the command syntax for all the tools. But because I've written a good set of notes on the other exercises I've done, I can just look up the commands in my notes. Okay. Oh, no worries about derailing. We're here to learn. We're here to talk. I do agree about note-taking. If you can find the info and develop the skills to relearn it swiftly, you can get through anything, just not as fast as the specialists. Are these the notes you take or the notes that you look up? So you take the notes, you look up the notes. This is why I've got so many write-ups on... This is why I try to do my best to keep notes for all the I do little walkthroughs for all the challenges that I've done in the past. Why is it taking such a long time to load up? So that if I encounter something that I've seen before, then I can look up the challenge and then maybe find commands that I used in the past. Okay, you don't use the skills, you lose them, but still remember the general paths and the tools. I mean, I forget the names of tools all the time. The problem is that I forgot the name of like a common Active Directory reconnaissance tool, and that's called Responder. So I forgot the name of the tool, and if you forget the name of the tool, it's hard to... I guess what I need to do is I need to write down a list of the tools and what they do. Okay, Yupley says, I work with a senior dev who created his own local wiki, and that's how he keeps notes, which was pretty cool to me. Yeah, that's awesome. But you know about them and define them. I guess, I mean, this is what I would do. This is another, use I could use for AI. So maybe I would ask, if I didn't remember the name of the tool, I'm thinking of a common tool that is used in Active Directory LLMNR poisoning attacks. What is the name of the tool? And it might be able to identify it like this. Right, it's Responder. It's just that we need to see if the AI can get the answer. Unable to start thread. Are you not responding because I'm talking about hacking stuff? Okay, so Pablo Ramirez says, do you have any platform where I can learn Python in the CTF style, or is it more practical and not bogged down in theory? Okay, it was able to... not able to. Hold on. Let me copy this. Let me put this in Google search. So this will be given to, like, Gemini. Is my internet connection down? Might have a service outage. Is that because I messed around with my... Streamworks. I mean, if my... what is wrong with my web browser? Maybe, yeah, it might be... It's always DNS. Okay, so what were we doing? Hold on. It might be this. It might be the name server thing. How to solve the CTF puzzle. Okay. Let me answer some of these questions. Let me get rid of this name server thing. Let's just delete that entry from resolve.conf. Okay. It's the bane of my existence is great. It's always DNS. It's always DNS. Okay, reload. Nope. Actually, wait. Is the name server supposed to be like 8.8.8.8.8? Let's go back in. Restart the stop service. Okay, you want to resolve it with Google. Can we Google.com? We can Google.com now. Okay. You can also use 1.1.1.1 with Cloudflare. Anyways, let's... So we're trying to ask Perplexity about this. So what I'm thinking of common tool that is used in Active Directory LLMR poisoning attacks. What is the name of the tool? So let's see. Responder. So it was able to identify the tool, so that's good. So the system D resolved service you're disabled is handling name server configuration. I think what we need to do is we need to add to the name server. We can use more than one name server at once, right? Okay, Frank E. Enjoyer says, I'm really engaged to expand my knowledge in cybersecurity, but I'm a bit confused. I don't know how to link practice and theory. Somebody was asking about Python, right? So do you have any... Pablo Ramirez asks, do you have any platform where I can learn Python in the CTF style, or is it more practical and not bogged down in theory? So what I'd say is you should probably complete a course. So do a course first, and I'll recommend a course to you. So we got our education resources on the HackerFrogs GitHub. For networking, the courses that I recommend are these two over here. So Python Essentials 1 and Python Essentials 2. So after you've got a good sense for coding in Python, you might want to try some challenges. So the challenges that I recommend are Exorcism. So Exorcism is a pretty good site for doing coding challenges. It'll help you build up some muscle memory for solving different problems using Python, for example. So Exorcism and like LeetCode, solving like easy LeetCode problems, solving exercises from Exorcism. It's probably the way you want to do it. But anyways, let's go back to the actual room we're trying to solve. Okay, so this is particularly useful because username enumeration via Kerberos does not trigger account lockouts. Failed pre-authentication requests are not counted as failed login attempts. However, it does generate Windows Event ID 4768 Kerberos authentication service requests on the domain controller, so it is not entirely silent. Oh, Advent of Code is also really good. Yeah, that's true. So try to solve problems from Exorcism, try to solve easy LeetCode problems, and try to solve Advent of Code problems. So that'll give you a good education as to how to get specific tasks done using Python. Okay, enumerating usernames. Place the username word list that is provided in a file at root_usernames.txt on the attack box. Let's use KERBroot to validate those potential usernames against the target domain. Okay, so here's what we're going to do. We need to download this file that has the usernames. Okay, we got usernames over here. Let's move it into our directory. So we're going to be doing some fuzzing here. So because KERBroot is brute forcing. So we'll just call this fuzzing. We'll give this tab a fancy color. How about some green? And we'll make a separate directory for this. So we'll call this breaching. And then we'll move the username list into this directory. Okay, so what we should have here is just a bunch of usernames. Let's check it out. Okay, bunch of usernames, that's great. And what we're going to do is we're going to be using the KERBroot tool. Advent of Code is cool for a different style of challenge. Yeah, I just read that, of course. Thank you. Okay, so we're going to have ads coming up in about a minute or so we'll just take a little break in about a minute. But in the meantime, let me copy down the command we're going to be using. So this is the KRBROOT tool. I'm pretty sure I've got it installed on my system. Let me give it a check. KRBROOT not found. Oh. It's not installed. Okay, you know what I can do? I can download the KRBROOT tool to my Kali box. So we'll search up KRBROOT, GitHub. Actually, let's see. So the link is over here. Brave Traveler, hey, what is up? That's a great set of emotes. Okay, so from here, this is the GitHub repository for the KRBROOT tool. What we want to do is we want to get the Linux AMD 64 version of the tool. So we'll just copy the link, and then we'll download it. So we'll wget that thing. Oh, that was a web page. No, it wasn't a web page. Okay, so this is the executable. Okay, we need to make this executable. Don't hack me, bro. No worries. We're not here to hack anybody who doesn't need to get hacked. But Rick, hello, nice to see you here. Dijkstra, right? That's how you pronounce your name, Rick Dijkstra? No, is it Dijkstra? Is it Dijkstra? It's Dijkstra, right? We were talking about this on another stream. Anyways, we got ads running on Twitch. We'll take a little break and we'll watch the birds for about a minute or so. Dijkstra, like the guy from the algorithm, of course. Okay, enjoy the birds. We'll be back in about 60 seconds. Pretty sure there's another bird that flies in that's a little bit more exciting than the sparrow here. Just a second. What we got? Here we go. So this guy right here. This is a spotted towhee. It is a very fun robin-sized bird. Well, a little bit smaller than a robin. It's got these really funky red eyes. Yeah. Anyways, let's go ahead and get back to our hacking. Okay, Kanbui asks, "Are you real?" I'm about as real as any other person on the internet is. Anyways, okay, we've got our KRBROOT executable over here. We're gonna make it executable with chmod plus x. And we're going to rename this because the name is a bit long. Okay, so let's go ahead and do our brute force attack. But first of all, let's make sure that our network is still up. So it says, let's see, network uptime 1 day. Let's go ahead and extend this. Network expire time updated. That's great. Okay, so they're going to teach us about how to do new username enumeration here. So we want to use KRBROOT username d thm.lock with the DC of this one over here, and then usernames.txt as the word list. So let's go ahead and copy this, and we'll run the attack. Of course, we need to make this a little bit different. Okay, so this is essentially the same command. We need KRBROOT in username enumeration mode, we specify a domain controller, which is, well, no, not a domain controller, a domain, which is thm.lock. We have to specify the IP address of the domain controller in this case, which is this one over here. And then the word list we're going to be using to brute force, which is the one that we've included in this directory here. So we run the command. Oops, we need to // this. Okay, so it says using KDCs, and we've got our IP address for the domain controller on port 88. Of course, port 88 is the port that Kerberos works on. And we'll just wait for this to resolve, but in the meantime we can read a little bit more about this. Okay, you should see output followed similar to the following. Yeah, so apparently we're supposed to be able to find 3 valid usernames. Each line marked with valid username represents a confirmed domain account. These validated usernames now form our target list for subsequent attacks. We will use them for password spraying in Task 5, and they may also appear in credentials discovered in Task 4. You can save Kerberoot's output to a file using the -O flag for easier processing later. Yeah, okay. So we've also got DNS enumeration. Alongside username gathering, it is worth performing basic DNS enumeration to identify key services in the AD environment. DNS is the backbone of AD. Domain controllers, mail servers, and other critical infrastructure are all registered as DNS records. A few useful lookups include NS lookup. Okay, and what are we looking for? So identify domain controllers via SRV records, identify the Kerberos KDC, and identify mail servers. So these queries help us map out the environment before we start launching active attacks. Knowing where the domain controllers, mail servers, and other services sit gives us a clearer picture of the network topology. How many valid usernames did Kerberoot discover? Looks like it is more than 9. Okay, let's go back. Huh. So it looks like we haven't found anything yet. That's kind of weird. Let's do a little sanity check. We don't have access to the server anymore. That's no good. Error TLS handshake failed. Did we crash? I don't know. Let's see if we still have a connection. So we still have a connection. Okay, let's see if we can contact the domain controller. Yeah, it might have been the name server. Let's try pinging this thing. Yeah, we can't ping it. Yeah, redo the VPN? Maybe. Okay, let's reconnect. So platform access, restart OpenVPN. It doesn't look like we're connecting. Hold on. Is the network down? Let me go back up to the top. Network paused. Oh. Okay. So let's unpause it. Yeah, looks like the network reset for some reason. Let's see. When there are enough votes, the network will reset to its default state. I blame THM. Well, I mean, The thing about THM is that even though the infrastructure can be a bit spotty, it is really nice that we have access to all these different education materials via THM for free. Well, not all of them are free, of course, but there's a lot of free stuff here. Okay, let's reload the page. To teach our AI replacement. Yeah, maybe. Okay, so it looks like it's up. Are we online? Okay, let's do that ping. Okay, we've got connectivity again. Great. Okay, now we can run the fuzzing tool, curb root. Okay, we found a bunch of valid usernames here. And I think they said that we could output this to a file with the -o. Okay, and let's see what users.txt has. Okay, well, I mean, we still need to format this. Well, I mean, we've got these valid usernames. That's good. We just need to format this because we can't do very much with. Well, I mean, we just want this. We don't want all this other stuff. So it's something like cat users, and then pipe it out into cut D. Cut D by name, field 2. No, delimiter has to be a single character. Okay. Cut D by colon. Field 5. Nope. Okay. So cut D by colon gets us the most of these usernames. So we just need to cut D by colon, field 4, and then delete tr delete spaces. Deleting spaces didn't do anything. Oh, do we need to delete tabs? Is that a tab? TR space with nothing. TR space with nothing, like this. Extra operand, what is this? TR delete tabs. Okay, so we'll pipe that into TR delete /t. Okay. This is almost... We just need to put this into a file. Okay, we just need to go in and modify this just a little bit. Because there's an 88 here, which we don't want, and there is a couple of new lines here. Okay, so this is what we want. We have users.txt, which is just the usernames, and what are we doing after this? We want to run our NS lookup. So NS lookup for DNS enumeration. Oh, they wanted to know how many users are here, right? So let's see. How many valid usernames did Kerberoot discover? So we'll just cat this out and then pipe into WC. So there's 43 lines, so 43 users. What do you mean by no? How many valid usernames did Kerberoot discover? Did I accidentally delete something? Hold on. Let's run Kerberoot again. Okay. So administrator, Claire. Did I accidentally delete something? So the first user should be administrator. The last user should be SVC. Oh. The administrator user is still here. What happened? Shows 43 valid at the bottom. Kerberoot said 43. Okay. "43 valid. So why doesn't it want to accept this? How many valid usernames did Kerberoot discover? 43. It doesn't like that. What is the organization's username format? I mean, the username format is... It looks like first name dot last name. So it's first dot last. Yeah, I don't know why it won't accept 43 as the answer. 44, yours was not counted. I mean, maybe we're omitting the administrator user. Apparently we're... Well, I mean, either we're omitting the administrator user or we're omitting the service user. Service.jenkins. But, okay. So it was looking for 42. I mean, maybe it was looking for 42 because it's a big fan of Douglas Adams. Okay. So let's see if we can actually run these commands. So nslookup, looking for server records. Okay, Martin says, I'm going to go to sleep, 3 a.m. Warsaw time. No worries, no worries. Hope you're, hope to see you again sometime there, Martin. Okay, so we found something. So we found ldap.tcp.dc, mdscs.thm.log. Okay, so this finds domain controllers. So the domain controller is definitely 192.168.12.100. Okay, and this next command is going to identify the Kerberos KDC. Right, let's give this a try. So the Kerberos KDC and the domain controller are very often the same server. So yeah, it's the same server in this case. And the last command is going to identify the mail servers. Okay, and there's no mail server in this case. No answer. So there's no mail server on this particular network, this particular Active Directory domain. Okay. Epistemic Anarchist says that the 100 IP address is the name server address, not necessarily the DC address. It was giving the DC host name in the SRV. No MX record configured. So yeah, I mean, there's no mail server. I guess there's no mail server on the domain. Okay, so we've answered these questions. We need to move on to credential stuff. Whether there's a mail server is a different matter. So no MX record. I guess that's true. It's not necessarily that there's no mail server completely. There's just no MX record. Okay, so thank you very much, Ervil Gamer 20, for subscribing on YouTube. Thank you very much. So the next thing we need to do is we need to do credential discovery and expose services. One of the most effective ways to obtain initial credentials is to look for them in places where developers and administrators have inadvertently left them. In many organizations, internal services such as Git repositories, CI/CD platforms, and file shares are poorly secured, and they frequently contain credentials in plain text. Credentials in plain text. This is often the path of least resistance during a breaching phase, and maps to the MITRE attack technique, unsecured credentials. Mail is older than DNS. Yeah, I mean, they had mail on ARPANET, right? Are they secured? That's a good question. Why exposed services are a goldmine? Developers and administrators regularly work with credentials as part of their daily workflows, including database connection, strings, service account passwords, API keys, and deployment secrets. Under pressure to deliver quickly, these credentials often end up stored in places they shouldn't be. Committed to source code repositories, printed in CI/CD build logs, written into configuration files on shared drives, or documented on internal wikis. Even when teams try to clean up after themselves, traces often remain. A password removed from a configuration file in the latest commit, for example, still exists in the Git commit history. Oh, yeah, we see this all the time in, like, cybersecurity CTF exercises. So Git records everything that you put in and everything that you delete from your commits, which means that even if you delete a password, the trace of the password still exists in the Git history. ARPANET had mail? yeah. It's an ancient technology that people are still using. Hunting credentials in Git repositories. Git repositories are often one of the most common places to find leaked credentials. Even if a secret has been removed from the current version of a file, Git's version history preserves every change. This means we can search through previous commits for sensitive data that was once present. Once you find an accessible Git repository, whether it's an internal GitLab instance, a Git server, or a misconfigured .git directory exposed via a web server, there are several places to look. Commit history. Developers often commit credentials temporarily and remove them in a later commit. The secret persists in the log. Configuration files. Files like .env, web.config, appsettings.json, config.php, and database.yaml frequently contain database passwords and API keys. Hard-coded secrets. Credentials embedded directly in source code, often left behind from development and testing. CI/CD pipeline definitions. Files like Jenkins file, .gitlab ci.yaml, or .github workflows star.yaml may reference credentials or reveal secrets are stored. To manually search through a repository's commit history, we can use git log with the -p flag to show the difference for each commit, and pipe it through grep to look for keywords. Okay? So for a more thorough and automated approach, tools like Trufflehog can scan an entire repository's commit history for high entropy strings and known credential patterns. SGA says, "Are you real?" Yeah, I'm real. I'm just reading out the stuff on the page. It may seem like I have an AI-like voice, but I'm pretty sure the AI doesn't inflect the same way I do. Anyways, hunting credentials in Jenkins? Advanced Frog AI, that's what I am. Jenkins is one of the most commonly encountered CI/CD platforms on internal networks, and it is frequently a treasure trove of credentials. Jenkins instances are often configured with weak or default credentials such as admin, and in some cases, authentication is not enforced at all. I want all the solid credentials. And hello, Gendry Fernando. Hello, nice to see you here. Okay, allowing anonymous access to the dashboard, build logs, and job configurations. There are several places where credentials can leak within Jenkins. In the build console output, build logs often print environment variables, connection strings, or development commands that contain credentials in plain text. Even when Jenkins masks credentials with stars, improper groovy string interpolation or custom scripts can bypass this protection. Job configurations. The XML configuration for each job, config.xml, may contain hard-coded credentials, especially in older or legacy jobs. Environment variables. Jenkins exposes environment variables to build steps. If a job prints its environment, for example using env or set, stored secrets may be revealed. And workspace files. Build workspaces may contain source code, configuration files, or development artifacts that include credentials. Okay, and Abdullah says, I tried but have no idea what you're doing. As a web dev, Linux enthusiast, because I'm a noob in hacking, but I will definitely come back tomorrow to check your other videos. Abdullah, yeah, I mean, what we're doing right now is we're trying to figure out how to hack Windows Active Directory networks. So the room that we're using right now is, you can access it for free over at TryHackMe, and it's a very good resource for learning about this because it lets you get access to a whole Active Directory network that you can hack against. Okay, so this was Jenkins. So if you can access the Jenkins web interface, start by browsing the build history and reading through the console output for recent builds. You can also access build logs directly via the Jenkins API. Okay, so you can use good old curl, and you can look for passwords, secrets, tokens, or credentials. Very cute. Practical exercise. In your lab environment, there are 2 exposed services to investigate. An exposed Git repository. Browse the repository and its commit history to find any credentials that may have been committed. So navigate here and see if you can find some passwords. Okay, if you say so. Alright, so what is this? Megacorp admin web app deploy. So... So we have to look through this file. We need to look through this Git repository to look for exposed credentials and tokens and passwords. Let's see if we can git clone this. So we'll just copy the URL and then use git clone. Okay, and that copies everything into web app deploy. So we'll enter that directory, and then we can start... Actually, is there a .git in here? There's a .git in here, okay. So the first thing we would do is we could just grep for something. So grep recursive, the current directory for... What was the pattern that they talked about? Password, secret, token, or credential. So let's start looking for those. Okay, no such file or directory. Didn't I set recursive? Well, I mean, we can look for password first. So we can look for password. Okay, we can look for token or credential, secret. Secret, token, deploy decoy credentials. Maybe. Token. Okay, so it doesn't look like we're getting anywhere here, but what we can do is we can do git log -p, and this lets us see all the commits. Let's see. It doesn't look like we're seeing everything. Oh wait, we can go down? We can go down. Okay. We can keep on scrolling. Grep directory, name, after options. Oh, directory name goes after options. Oh, okay. Okay, let's see if we can locate some credentials here. So onboarding password equals something. Okay, password, we've got one. So service Jenkins, password Jenkins 2025. So we'll just copy this, and I think we need to provide this as... We also have a secret key equals MC web app secret key, of course. Okay, what is the password for the service Jenkins account found in the git commit history? It's good that they point us towards where it would be. What default password was leaked in the Jenkins build logs? So we need to look in the Jenkins build logs. So the Jenkins instance is over here. Access the Jenkins dashboard and examine the build logs for any leaked credentials. Okay, Abdullah says, thanks for the info. I will check everything out tomorrow because it's a bit late in my time zone. Oh, by the way, what time are you live on tomorrow? Oh, I mean, we stream 2 times a week. We stream on Wednesdays and Fridays. So, hold on. So this is the Reddit over here. And we've got next week's schedule over here. Okay, so we're looking at the Jenkins dashboard. What were we looking for? We have to log in with admin. Sign in. Sure. Admin. Keep me signed in, please. And they want us looking through the build logs. Bird time? Oh, it is bird time. Okay, let's put on the birds and take a little break. Have a little bit of water. Here's the greediest sparrow. We'll be back in 60 seconds. So this is the greediest sparrow. It's not letting any of its friends near the food bowl. I think, does it get a little bit more... Yeah, it gets a little bit more aggressive here. Anyways. Wait, are you getting moderated? Anyways. These sparrows. Anyways, we'll put them away. We'll get back to the hack and stuff. So they want us to look through the build logs, right? Build logs, build history. Okay, so we got health check, we've got DB backup, we've got web app deploy. And let's just do them one by one. So the health check. Last build 25 days ago. No changes. Okay, and we'll check the... So the last build, last stable build, last successful build. Okay, so there's nothing... Don't think there's anything here. One more time, what are they looking for exactly again? Access the Jenkins dashboard and examine the build logs for any leaked credentials. So we're looking for credentials in the build logs. It's probably going to be in the database backup. Maybe in the console output. Ah, okay. All right, so the backup script over here, I don't think it... Check the console and the configuration. I think I've done this room. I remember Jenkins. Do you remember liking the room? So maybe, let's see. So build information is here. Changes, I mean, no changes, but we got the console output. Alright, so let's take a look at the other one. So the other one we're looking at was like health check, I think. So all builds, maybe web app deploy, health check. We'll take a look at the last build, and then we'll take a look at the console output. So health check, running a system, building in workspace, this one over here. And this doesn't look like it's exposing anything. We'll check the other one. So there's a health check, there was the database one, and the last one was the web app deploy script. Okay, let's take a look at the console output. Oh, here we go. Default password. Configuring new users' accounts with default password megacorp1. So we can just supply this as the answer for our question. Great. Okay, and we can move on to the next section, which is user enumeration and password spraying. Alright, let's read all about it. So by this point, we should have a validated list of usernames from Task 3, and potentially some partial intelligence from Task 4. Perhaps a default onboarding password, a naming pattern, and even a complete credential pair. If we haven't yet obtained valid credentials, our next approach is to try commonly used passwords against every username we've confirmed. This technique is called password spraying. So password spraying versus brute forcing. It is important to understand the difference between brute forcing and password spraying, as the distinction has a direct impact on whether or not we get results or lock ourselves out. Brute forcing targets a single account and attempts many passwords against it. This is effective against weak accounts, but will almost certainly trigger account lockup policies in an AD environment. Spray and pray? Well, I mean, password spraying is usually a lot more effective than doing brute force attacks. So password spraying takes the opposite approach. We try a single password against many accounts before moving on to the next password. By limiting the number of authentication attempts per account, we stay below the lockout threshold. Password spraying works because despite organizations enforcing complexity requirements, users tend to gravitate towards predictable patterns. So passwords like season year, for example summer 2025, the company name followed by a number, for example megacorp1, or a default password assigned during onboarding, are remarkably common across large user populations. Understanding lockup policies. Before spraying, it is critical to understand the target domain's account lockup policy. If the policy locks accounts after 5 failed attempts within a 30-minute window, spraying 3 passwords in quick succession is a recipe for disaster, as you will lock out every account on your list. A safe approach is spray 1 password at a time across the entire user list. Wait for lockout observation windows to reset before attempting the next password. If you already have 1 valid credential from an earlier task, you can query the domain's password policy before you spray. NetExec makes this very straightforward. Okay, so in this case we can use NetExec if we have a valid username and password to get the password policy. So for example, minimum password length 8. Let's see, account lockout threshold is 5. So if a user account has the wrong password, put in 5 times, then it'll lock the account. So reset account lockout counter, 30. Reset account lockout counter. So they'll reset the number of failed logins in 30 minutes, I'm assuming. Lockout account duration is also 30 minutes. Okay, great. So in this example, the lockout threshold is 5 attempts. The counter resets after 30 minutes. That means we can safely spray up to 4 passwords per 30-minute window without triggering lockouts. So if you don't yet have any credentials to query this policy, the safest approach is to assume a conservative lockout threshold and spray only 1 password at a time with a generous delay between rounds. Spraying with NetExec. NetExec is a powerful network exploitation tool and the successor to the now archived CrackMap exec. It supports authentication testing across multiple protocols, including SMB, LDAP, WinRM, RDP, and MSSQL, making it an ideal tool for password spraying. Before we can spray, we first do a little bit of cleanup on our output from Kerberoot. Okay, so this valid username, they do something very similar to what we did. Okay. Let's spray a single password against our validated username list over SMB. If you saved your valid credentials from task 3 to a file, you can use it directly. Okay, so we're going to spray this password against all of the users on the password list, on the user list rather. Okay, let's demonstrate how to do that. So we're just going to copy this, and we're going to go over to our fuzzing window. Okay, so we saved our... Oh, we're in the wrong directory. Okay, here we are. So we got our usernames list over here, users.txt. So we're just going to run netexec on all the users in users.txt using a single password, which is this megacorp1 password. And we're going to continue on success. So if we find a successful match, we'll keep on going. So when we run the command, okay, it'll go through each username in the list. So there's 43. And it's going to try the password megacorp1. So it's not super quick, but it does get the job done eventually. But in the meantime, so when we run that command, we need to specify the protocol for authentication, for example, SMB, the IP address of the domain controller, the file that we use for our usernames, our password, and continue on success. Okay, interpreting the results. So the output tells us several things at a glance. So when we see a plus, that means it's successful authentication. If we see status logon failure, or status account disabled, or status account locked out, that means that we failed. And we see the pwned flag over here if the account has local administrator privileges on the target host. So this is an even bigger win than the standard domain user. Okay, so let's go ahead and go back to... Did we not find anything? Huh. We didn't find anything in the attack. That's interesting. Let's try the other password. So we found 2 passwords. We didn't find anything from megacorp1, but there was another password we found, which was... Jenkins 2025. So we'll try this one as well. I think the username format was wrong. The username format was wrong. So Zoe Murphy, so it's like first last? No, I think it was correct. Huh. Let's try this one. So status log on failed, huh? I've got the domain twice. Do I? Oh. Yeah, the format looks a bit weird. You need to strip the THM lock from the username list. Okay, hold on. Name users.txt. Ah. Okay. So we might need to get rid of this. So how do we snip that off? So we could probably do like cut D at symbol, return field 1. Whoops, we need to provide a U. Okay, so that looks good. Let's just make sure that there are no spaces in there. Okay. We'll create a new users.txt out of that. I think they had set in it for the guide. I mean, we don't need to do exactly what the guide says as long as the output is the same. Okay, let's try running the thing again with the Megacorp password. Why didn't that... Why didn't it run? Hold on. Okay. Did the server go down again? Let's go back up to the top. Extend. Let's reload this page. For some reason, it wasn't. Okay, so the network's still up. That's good. Let's see if I can ping the target. Okay, we can ping the target. Users.txt, Megacorp1, continue on success. Let me make sure that users.txt is blank. Oh, okay. Users.txt is blank. That's great. Alright, I need to go in and I need to edit this thing again. What was that command? Okay, so let's just make sure that we're getting the right stuff. So this is what we have now. Then we need to cut off the @thm.lock. So cut the delimiter at field 1, and then make sure that there are no spaces, and then put that into users.txt. Okay. Let's run the whole thing again. Okay, great. Looks like it's working. So we're waiting on this. I mean, we can afford to just wait for this thing to play out because there's only 42 names on the list. We found one. Okay, dev.intern megacorp 1. So now that we've got a valid set of credentials, oh, we've got 2 valid sets of credentials. Okay, because there's only 2, we can record these. So we would echo out something to creds.txt. So for example, this one, and the other one, which was Alice Moore. Like this. So we got two sets of credentials, and from here, what we can do opens up a lot inside of Active Directory. We can do all sorts of queries now that we have these. Now that we have a valid user on the system. Okay, so which thing were we on? We were doing password spraying. Okay, other spray targets. In this task, we sprayed against SMB on the domain controller. However, password spraying can also target other AD integrated services, including Outlook Web Access, OWA, RDP, VPN portals, and LDAP. These alternative spray targets will be explored in later rooms. NetExec supports many of these protocols natively. You can simply swap SMB for RDP, LDAP, WinRM, or MSSQL in the command syntax. So how many accounts were cracked using the brute force attack? So we were able to get 2 valid sets of credentials. And what is the first user account alphabetically that uses the default onboarding password? So this was like, what was it called? Like intern something something? No, it's Alice Moore. Alice.Moore. Okay, and the next thing we're going to be learning about is coercion attacks. So, introduction to authentication coercion. So far, we've looked at techniques that involve either discovering existing credentials or guessing them. In this task, we'll explore a different approach entirely called coercion attacks. Instead of searching for credentials or spraying passwords, coercion attacks trick a device or user into sending authentication material to an attacker-controlled listener. This maps to MITRE ATT&CK technique, forced authentication. We will cover 2 beginner-friendly coercion techniques: an LDAP passback attack against a misconfigured network printer, and file-based coercion on a writable file share. But first, what is an LDAP passback attack? Many network devices such as printers, scanners, and multifunction peripherals, MFPs, integrate with Active Directory via LDAP to support features like scan to email, address book lookups, and user authentication at the device panel. To make this work, the device stores a lot of LDAP credentials, typically a service account, that it uses to bind to the domain controller and perform directory queries. An LDAP passback attack exploits this by redirecting the device's LDAP connection to an attacker-controlled listener. The attack flow is straightforward. 1. Access the device's web-based administration interface, the embedded web service, often using default or weak credentials. 2. Navigate to the LDAP configuration page. 3. Replace the legitimate LDAP server IP address with our attacker machine's IP address. 4. Trigger a connection test, as most devices include a test connection or check connection button for exactly this purpose. 5. The device sends the stored LDAP credentials to our listener and we capture them. Why does this work? MFPs and IoT devices are among the most overlooked assets during security hardening. Common issues include default admin credentials. Devices are deployed with factory default credentials and never changed. Common defaults include admin, HP, admin, colon with the blank passwords Rico and admin canon for canon. Overprivileged service accounts. The LDAP service account is sometimes a domain admin. Wow. The LDAP service account is sometimes a domain admin, far exceeding what is required for directory lookups. Plain text LDAP, port 389. Many devices are configured to use unencrypted LDAP rather than LDAP-S, port 636, meaning that credentials are transmitted in clear text. No credential rotation. Service account passwords for device integrations are rarely rotated, meaning a captured credential may remain valid for months or years. Performing the attack. In the lab, a network printer is accessible with its webadmin panel exposed. Let's walk through the attack. Navigate to the printer application on printer.thm.lock. Okay. First, access the printer's admin panel using admin in your browser and locate the LDAP configuration page. You should see the current LDAP server IP and port, along with the service account username. The password field will be masked, but the device still stores the password internally. Okay, so let's go ahead and navigate to the page. So this is the printer administration panel. So admin to sign in. Okay, we've got model, serial number, firmware, status, MAC address. And what we're looking for is the LDAP settings. So LDAP server address. Yep, we're doing LDAP stuff. So LDAP port and bind DN, binding password. So the service account is this one over here, svc.ldap. Okay, and we've got a simple authentication method. That's good. Connection security plain text on port 389. So 389 is the unencrypted LDAP, as opposed to the other port for LDAP, which is encrypted. So let's go ahead and supply our own server address, which is our attacker machine IP address. This one over here. I think the way we're going to be doing this attack is that we're going to set up a listener on port 389 on our local machine, so that when we do the lookup or we do the check, the credentials for the LDAP service is going to be sent to our attacker machine. So it's going to be something like, let's see, I don't have a, we're just going to call this our localhost services. And let's go ahead and set up a Python server. So Python module HTTP server on port 389? 389. So I'm not too sure if we should be doing a Python HTTP server, because I'm pretty sure we're not dealing with HTTP in this case. Thank you very much for subscribing, lots. Thank you. So we probably want to set up like a netcat listener, right? So netcat NLVP on port 389. And let's see if we can catch it. Okay, and we'll test connection. And it looks like we didn't receive anything. Huh. Why is the LDAP server configuration got reset? Hold on. Let's copy this. Do we need to save this information first? Save settings. Okay, we need to save the settings first. And then we need to test the connection. Okay, we found something. Okay, we got a connection from the printer, service.ldap, and then we got a password. So print bind 2025 exclamation point. So we'll just save this set of credentials, echo to creds.txt. So this is for svc.ldap. Okay, so we've got 3 sets of credentials now. And we can move on to the next section. Although I guess they're going to ask us for the password, so I'm going to copy this. SysOS says, if set up correctly, that bind password would only work from the printer IP and name. If it was set up correctly. Well, I mean, security and security flaws are all about misconfigurations, aren't there? Verify the captured credentials, so they wanted just to... Oh, they want us to verify, huh? Okay, so they did the same... Huh. Why is there a typo in here? That's weird. Okay, so if we wanted to verify the password, we could do that with netexec. So we would netexec with this password and the username svcldap. Just like this. So if the status account disabled. Okay, so I think the reason why it doesn't work is because we're using the wrong protocol. Okay, we've got birds. It's time for birds in water. Yeah. All right, let's put on the birds. This is my favorite video. Check out these birds. We'll be back in 30 seconds. Okay, everybody, let's get back to the hacking. Mohammed, hello, nice to see you here. What is up? Daily Dose. A Daily Dose video? Some people have said that my voice sounds kind of like the Daily Dose guy. Okay, so let's replace SMB with LDAP and see if the credentials work. Status account disabled. Huh. So LDAP, account disabled. What other protocols can we try? So this should be communicating over LDAP. So I guess we can't use this service account. Verifying the captured. Oh, okay. So we're supposed to get this response. So this is supposed to be account disabled. Okay, so confirms valid domain credentials, but sadly this account is disabled. No matter, there are other ways we can look to breach the perimeter. What is file-based coercion? So file-based coercion takes a different approach to forcing authentication. Instead of reconfiguring a device, we place a specially crafted file on a writable network share. So this is something that I've heard from my pen tester friends who do network pen testing. They say that this kind of attack works all the time. Okay, and thank you very much to Mohammed Galban for subscribing on YouTube. Much appreciated. Thank you very much. Okay. So instead of reconfiguring a device, we place a specially crafted file on the writable network share. When a user browses that share using Windows Explorer, the operating system automatically attempts to render the file's icon. If the icon points to an UNC path on the attacker machine, for example, ton0ip share icon.ico, Windows will follow that path and send the browsing user's NTLM v2 hash to our listener, all without the user opening or clicking the file. This works because Windows Explorer renders icons and thumbnails for files in a directory as soon as it is opened. Certain file types, including .url, allow an icon file field that specifies where the icon should be loaded from. If this field contains a UNC path to an external host, Windows will silently initiate an SMB authentication attempt to that host, leaking the user's NTLM v2 hash. What's a UNC path? That's a good question. So I'm not super familiar with that acronym. Windows UNC path. Universal Naming Convention path, a standard format for accessing shared files and devices on the local network. Okay, so Universal Naming Convention. So the UNC path always starts with a double backslash. Oh, okay. So a UNC path is something that looks kind of like this. Okay, let's copy that. So a UNC path would be something like... Huh, why didn't that copy? Copy... Huh, doesn't want to... Hold on. Copy. Paste. So this is an example of a UNC path. There you go. So this is something that you see pretty often when you go over to your File Explorer in Windows. So for example, like a UNC path could be something like // what is the word? Users / the shy hat / documents. So this is an example of a UNC path. Okay, let's continue. Okay, so user sends NTLM negotiate, which attacker intercepts with poisoning. What is this? So basically, when a specific type of file has information inside of it that points to, for example, your attacker machine as the place to look for the icon file, for example. So whatever machine accesses that file is going to reach out to your attacker machine, and in doing so, it's going to leak out the NTLM hash for the user that is navigating in that file share. So historically, .scscf shell command files and desktop.ini files were used for the same attack. However, Microsoft has patched these vectors on fully updated Windows 10 and 11 systems. .url files remain effective on current Windows versions and are a recommended technique for this attack. Creating a malicious .url file. The syntax for a URL file is minimal, including just a few lines in the INI style format. So URL is something, working directory is something, icon file is your attacker controlled domain or your attacker controlled IP address. So let's see. Okay. Important, the EOF without quotes is deliberate. Without these quotes, Bash will interpret the double backslashes in the icon path file as single backslashes, resulting in an invalid UNC path that won't trigger authentication. Okay, let's see. Right, would it be nice to have a sample.printer? Sample.printer. I mean, let's just get the do they want us to create a file called @shortcut.url? Note the file name. .shortcut.url, deleting @ character ensures that the file sorts to the top of the directory listing in Windows Explorer, which means it's one of the first files rendered, maximizing the chance that the icon is loaded as soon as the user opens the share. Okay, and then we also need to set up this tool that I was talking about earlier, which is responder. Responder.py. Okay, look up NTLM theft, it will help with the file generations. NTLM theft, is that like some sort of helper tool? But Hexecho, thank you for letting me know about that. Okay, so no, I don't have it installed in here. Okay, so let's create a file called, what was it? They want us to name it like shortcut something? @shortcut URL. And then put this thing in. Wait, we don't actually need the EOF in here, do we? No, I don't think we do. Yeah, you don't put the EOF in the file, that's just escaping the shell redirection. Anyways, let's go back in, let's get rid of this. We just need to replace this with our IP address. So our IP address is this one right here. Okay, and then we can save out the file. And we need to put this in a file share. We need to upload this to a file share, and we also need to start up our responder NTLM thing. Python tool for generating different types of files that would trigger. Oh yeah, NTLM theft. Let me see if I can find the GitHub repository for this. GitHub. Yeah, this one right here, I assume. If you're interested in trying out the tool yourself, here it is. Okay, a tool for generating multiple types of NTLM v2 hash theft files. Okay, but what do we have? Which distribution are you using? Be better, hello, nice to see you here. I'm currently using some Kali Linux. So if you name A. So this is the HackerFrogs host. It is using Kali Linux, which is a Debian-based distribution. Okay, so let's break this down. The file type header, the URL. For a shortcut that you're pointing to, this can be anything. Working directory, a working directory for the shortcut. Oh, the working directory for the shortcut. So this needs to be put in the THM directory. Setting up responder. So before placing the file in the share, we need a listener to capture NTLM to v2 hashes. Responder is the go-to tool for this. It listens on multiple protocols and captures authentication material. So we run responder and then give it an interface. In this case, it's the ton0 interface that we need to be listening on. So it's going to listen for incoming connections, and if it finds one, then it'll give us the NTLM-v2 hash. Okay, Mohammed says, I just finished my first year in network and security engineering. I have a good foundation in Python networking, hardware, and software. Is it enough to start TryHackMe? I'd say yeah. I'd definitely say yeah. And, well, you can go over to TryHackMe and give it a try. There are a bunch of other different places. There are a bunch of different places you can get your education for different types of hacking. I've got a bunch of education resources over here if you want to take a look. Okay, so let's run Responder. I'm pretty sure I've got it installed on my device. Let's make a separate tab for this. Okay, so Responder is running now, so it's listening for incoming connections from machines. If it receives any incoming connections, it'll tell us the NTLM hash, so we just need to leave this running right here. Okay, Responder will listen on port 445, SMB among others, and capture any NTLM-v2 hashes that are sent to our machine, placing the file and capturing the hash. Now upload the malicious.url file to a writable share. You can use SMB client to connect to the share and upload the file. So in this case, they're assuming that we did enumeration to figure out that this user has access to the shared docs folder on server 1. So this is how we would confirm this. server1.thm.lock. Okay. So the way we would confirm this kind of thing, and let's just call this our... Actually, we've got another netexec thing over there. Just a second. Okay, so netexec... We've got our credentials over here, and what we'd normally do is we'd try to figure out what file shares are available for these users. So in this case, we would look over SMB, and we would put in the credentials of this user here, so Alice Moore, and give the password megacorp whatever, this one. Okay, how do you make a terminal like that? Root, hello, nice to see you here. So this is the default terminal program for Kali Linux. It's called like QTerminal. So Qt, QTerminal, and what you can do inside of QTerminal is you can go over to the session tab up here and then create a new tab. And you can make a bunch of different tabs, and then, you know, you can label them all, you can give them different colors. It's a pretty handy-dandy tool. The other thing you could do if you want to set up your terminal is you could use tmux, which is a pretty common program a lot of people like to use as well. Okay, so we want to figure out what file shares these people have access to. So Alice Moore. And probably none on... Oh, wait. We need to check a specific server. I think the server they're looking for was... this one over here, server1.thm.lock. So we'll just copy that. and then we'll check for them for their file shares on this server. So we see this user has read and write permissions on shared docs on this particular server, server1.thm.lock. So what they're trying to do, what they want us to do is they want us to upload the malicious file shortcut.url up to this file share. So we can use smb client / server1.lock shared docs. And we need to specify a user, and the user is going to be alice.moore. I think this is how you do this command. Shadowhunter asks, which OS are you using? We're currently using Kali Linux. Oh, I think it has to be like capitalized. Okay, so they're looking for the password. We've got the password over here. We'll paste it in. Status logon failure. Really? Hold on. So SMB client. You need the domain. Oh, we need to include the domain with our user? Okay, sure. Alice.moore at thm.lock. Oh. Okay. Okay, now we're logged in. Great. Alright, thank you very much, HexPsycho, for the advice. Yeah, apparently we needed to add the domain to the end of this. So alice.moore didn't work, but alice.moore.thm.look did. Are you really performing illegal activity? No. We're not. We're doing an educational exercise. So the educational exercise can be found over here. We're learning how to do Windows Active Directory hacking. Okay, so there is a bunch of stuff over here. Huh. People have already been putting in their URL shortcuts, huh? Alright, it looks like I need to rename my shortcut. Okay, let's rename it. So move at shortcut. And then we're going to call it AAA shortcut, so that it is the first thing. Still moving quick enough for Hollywood? Well, I don't know if anybody would be super into this if they were watching it on the big screen. Okay, we need to upload this. So let's see. Put at AAA shortcut.url. Okay, so we've uploaded the thing. So now we see that it is here. Huh. We need to make it capital A. Okay, so let's take a look and see if our responder picked up anything. Okay, we got a hash. So we got a hash for a user that accessed the file share, and it's THM Sarah Jones. So THM Sarah Jones, and we've got an NTLM hash here. So what we need to do is we need to crack this hash to figure out the password for this user, Sarah Jones. So we're just going to copy this, and we're going to add this to a file. So sarah.hash. Okay, and then we'll just save that out. So there's specific programs we can use to crack this hash to find out the actual password for the Sarah Jones user. So I'm pretty sure they're going to recommend to us to use like John the Ripper or something, or Hashcat. Okay, now we wait. When a user browses to share, Windows Explorer will attempt to load the icon from the UNC path. Back on your responder terminal, we should see the captured NTLM v2 hash. So this one over here. We have captured an NTLM v2 hash. However, unlike the LDAP passback attack, where we obtained a plaintext password, this is a net NTLM v2 hash, which cannot be used directly for pass the hash attacks. We need to crack it offline. So the next thing we're going to do is we're going to crack the hash with Hashcat. Before cracking the hash, we need to save it to a file. So we're going to name it hash.txt or whatever we want. We can crack the NTLM v2 hash with Hashcat using the mode 5600 or NTLM v2. So use command strad or based. I mean, I'm not too sure. I don't know if I know those commands. Okay, so we can copy this command over here, Hashcat. So Hashcat is basically a brute forcer. It's it is a password cracking program. So what it does is it tries a bunch of different hashes according to whatever word list you give to it to try to figure out if the hash is the hashed version of one of these words in the word list. So okay, so we've copied it, and we're going to give this a try. So we're not running it on a hash.txt, we're running it on sarah.hash. So when we run this attack, if we are able to find a correct password inside the word list, so RockU is a really big file with like 14 million different passwords. If one of the passwords matches the hash, then it'll report it back to us. Okay, so the Hashcat program is GX000. Hello, nice to see you here. What is up? Nice to see you. Hope you're having a good week. Okay, so we're just doing a bit of hash cracking over here. We're doing a module where we're trying to figure out different techniques for doing Active Directory breaching. It's a pretty good room. And if you want to refresh your memory about Active Directory hacking stuff, you might want to take a look. Okay, so we managed to crack the password, and the password in this case is trust no one. That's a great password. So we can add this to our list of credentials that we've managed to find. So we're going to echo out to creds.txt. It's sarah.jones and trust no one as the password. Just like this. So we've got our collection of credentials that we managed to find in our file over here. Okay. So once cracked, we have another valid set of 80 credentials obtained without ever spraying a password or discovering an exposed secret. A note on advanced coercion techniques. The two techniques covered in this task are just the tip of the iceberg when it comes to authentication coercion. More advanced techniques, including petit potam, printer bug, spool sample, and DFS coerce, can force domain controllers and other high-value machines to authenticate to an attacker-controlled listener. Combined with relay attacks, where you forward the captured authentication rather than cracking it, these techniques form some of the most potent AD attack chains available today. These will be explored in depth in dedicated rooms later on in this module. Okay, so what is the bind DN of the service account captured during the LDAP passback attack? The bind DN of the service account. Bind DN of the service account. Okay, I think we need to go back to the LDAP thing here. Bind service account. So this is it here. I guess we can just copy and paste. Okay, and what is the plaintext password captured from the LDAP passback? So the plaintext password we collected in here, print bind 2025. Okay, and lastly, what is the cracked password for Sarah Jones obtained through file-based coercion? So I think it was like trust no one, like this. Okay, and then we're coming up pretty close to the end of this room. We got mitigations. Now that we've explored several techniques for breaching an AD environment, let's shift perspective and look at how organizations can defend against them. Understanding mitigations doesn't just make you a better defender, it makes you a better attacker. Knowing what controls to expect helps you identify when they're absent and adjust your approach accordingly. Below is a summary of defensive measures mapped to each breaching technique covered in this room. Secrets management. Credentials in Git repositories, CI/CD build logs, and configuration files were among the easiest wins in our engagement. Mitigating this requires a disciplined approach to secrets management. Use a dedicated secrets vault, such as HashiCorp Vault, Azure Key Vault, or AWS Secrets Manager, to store and retrieve credentials rather than embedding them in source code or configuration files. Sleepy Ninja says, I really need to get back into the red team, so much more fun than blue. Sleepy Ninja, are you currently working in a blue team role? Implement pre-commit hooks using tools like TruffleHog or Git. Oh, we got ads running right now. Hold on. It's time for the birds. Okay, we'll be back in about 50 seconds, but enjoy these birds having an argument. Hello Iqbal, nice to see you here, and let's go ahead and put away the birds and we can get back to the last parts of this room. Okay, Sleepy Ninja says, I do vulnerability management. Oh, okay, that's awesome. And Local Can says, I like baseline sampling remediation and all the things either way. Okay, so regularly audit existing repositories for historical credential exposure. Remember, a secret removed in the last commit still exists in Git history. Rotate credentials immediately when exposure is detected. Removing the secret from the code is not enough. The old credential must be invalidated. Mask or redact secrets in CI/CD build logs and restrict access to build output to authorized personnel only. Password policies and account lockout. Password spraying was effective because users chose predictable passwords that met complexity requirements on paper but were easily guessable in practice. Strong password policies should include a minimum password length of 17 or more characters, banning common passwords in organization-specific patterns, avoiding organization-wide default passwords for new accounts, configuring account lockout thresholds carefully, and monitoring for distributed authentication failures across multiple accounts. We can also do device hardening. The LDAP passback attack relied entirely on a printer with default credentials and a plain text LDAP configuration. Hardening network devices involves changing default administrative credentials on all network devices, including printers, scanners, NFPs, and IoT devices, before deployment. Using LDAPs with an S on port 636 instead of plaintext LDAP on port 389 for all directory integrations. When LDAP traffic is encrypted, a passback attack captures an encrypted session rather than plaintext credentials. Restricting access to device admin interfaces by IP addresses or VLAN. These interfaces should not be accessible from general user networks. Using dedicated low-privilege service accounts for device LDAP integrations, never in domain admin or other highly privileged account. The service account should only have read access limited to a specific directory objects the device needs, such as address book lookups. Including network devices in regular vulnerability scanning and asset management programs. File share security. File-based coercion was possible because a share had overly permissive write access. Securing file shares requires enforcement of the principle of least privilege on share permissions. Users should only have write access to shares where they genuinely need it. Monitoring shares for suspicious file types such as .url, .lnk, .sfc, and desktop.ini files. These should rarely appear on data shares and be flagged by file integrity monitoring or endpoint detection rules. Auditing share access to detect anomalous patterns, such as a new file appearing followed by a burst of SMB authentication attempts to an external IP. This would be a pretty obvious pattern, yeah. NTLM hardening. A file-based coercion attack captured on NTLM v2 hash because the victim's machine automatically attempted NTLM authentication to our attacker-controlled listener. Hardening NTLM involves disabling NTLM v1 entirely and enforcing NTLM v2 as the minimum authentication level via the group policy. Network security LAN manager authentication level set to send NTLM v2 response only, refuse LM and NTLM. Enforcing SMB setting on all domain machines to prevent relay attacks that intercept and forward NTLM authentication. Blocking outbound SMB traffic at the network perimeter firewall. There is rarely a legitimate reason for internal workstations to initiate SMB connections to external IP addresses. Working towards NTLM deprecation where possible. Microsoft has begun the process of deprecating NTLM in favor of Kerberos, and organizations should plan their migration accordingly. Network segmentation and access control. Many of the techniques in this room were possible because services were accessible from parts of the network where they didn't need to be. General network level mitigations include segmenting the network so that management interfaces, printer admin panels, Jenkins dashboards. I'm getting tired. Printer admin panels, Jenkins dashboards, Git servers are only accessible from dedicated management VLANs. Restricting access to internal services that do not need to be broadly available. A Jenkins instance used by the development team should not be reachable from the general corporate network. Enforcing multi-factor authentication, MFA, on internet-facing services and critical internal services such as VPN portals, email, and remote access gateways. MFA significantly reduces the impact of breached password as the credential alone is no longer sufficient to authenticate. SysOS says you need a text-to-speech tool and do the reading for me. I enjoy doing the reading as well. Maybe I need to. I think I learn better if I say the words out loud. Anyways, let's answer the questions. What group policy setting can be configured to enforce NTLM v2 and refuse older LM and NTLM responses? So group policy setting, I think they were talking about this one. Check that. What port should be used instead of port 389 to ensure LDAP traffic is encrypted? So we're talking about port 6 something something, right? Where was it? LDAPs. So the secured version is 636. Check that. Okay, and then our conclusion. Okay, Null6 says, I could train a model on your voice. JK, I find that creepypasta. I mean, you should have permission to create like a deepfake version of your own voice if you want to use it as a tool for narration or something. But using other people's voices for deepfakes, that's not so great. Okay, conclusion. Well done. You've gone from 0 credentials to multiple valid domain accounts, and you did it through several different avenues. That's the reality of AD breaching. It's rarely a single technique that gets you in. It's a combination of reconnaissance, opportunistic discovery, and creative coercion that opens the door. Let's recap what we covered in this room. OSINT and reconnaissance. We gathered potential usernames from public sources and validated them against the domain using Kerberoot, exploiting Kerberos pre-authentication behavior to confirm which accounts exist without triggering lockouts. Credential discovery. We hunted for secrets in commonly exposed services, Git repositories with credentials buried in commit history, and Jenkins instances leaking sensitive data through build logs. Password spraying. We took a single password and sprayed it across our validated usernames using netexec, staying below the lockout threshold while identifying accounts with weak or default passwords. LDAP passback. We exploited a misconfigured network printer by redirecting its LDAP authentication to our listener, capturing the stored service account credentials in plain text. And file-based coercion. We planted a malicious .url file on a writable share, forcing a user's machine to send us its NTLM v2 hash to our responder listener. We then cracked the hash offline with Hashcat to recover the plaintext password. Each of these techniques gave us a different way in, and in a real engagement, you would use whichever combination the environment presents to you. What's next? This room covered the breadth of AD breaching. There will be deeper rooms in coming modules that will provide the depth, diving into techniques that we deliberately kept out of scope here. So, null sessions, guest access, LDAP anonymous builds, anonymous binds, and SNMP enumeration. Advanced coercion techniques such as petit potam, printer bug, spool sample, and DFS coerce. NTLM v1, 2v2 relay attacks, forwarding captured authentication instead of cracking it. LLMNR and MBTNS poisoning for credential interception on the local network. PXE boot abuse and MDT credential extraction. And a capstone challenge combining all breaching techniques into a single engagement. Before moving on, consider going back through the lab and trying the techniques again. Repetition builds the muscle memory that separates reading about an attack from executing confidently on an engagement. I have completed the introduction to AD breaching room. Yay! Let's click on that and finish. Okay, so that was a great little refresher. An interesting thing about this particular room is that I'd seen most of the techniques that were being talked about, but there were a couple that I had that were completely new to me. So the stuff that was new to me in particular was the coercion attacks. So the LDAP passback attack I hadn't seen before. But I think we've done something kind of similar on other exercises. But it's good to know that this kind of thing is possible when we're dealing with network printers. Local Kansas, reading aloud probably does help with retention. I mean, you're reading it and you're saying it out loud, so you're hearing it. So it might help with memorizing something. Yeah. So the LDAP passback attack was new to me. And the other attack with uploading the file-based coercion attack, this is something that I'd heard about, but I haven't really tried myself before. So it was nice to be able to conduct the attack myself. Okay, So let's oh man, I'm pretty tired at this point. I might be ending the stream soon, but before we do that, let's talk about what we're going to be doing next week. So next week is week 22 of 2026. We're almost at the halfway point of the year. So what are we going to be doing next week? So next week we're going to be doing Web App Wednesdays. So Web App Wednesday is going to be on May 27th. We're going to be doing more AI stuff. We're going to be doing demos for Pico CTF 2026, general challenges. I think I've got quite a few more general challenges to work through. I'll be doing some demos and explaining the techniques we use to solve those challenges. We're going to be doing Digital Forensics Session 7, which means we're going to be doing some... What are they called? It's called like memory forensics, right? So we're going to be taking a look at memory pulled directly from devices and doing forensics on it. And we're also going to be doing TryHackMe Intro to OT ICS. So this is a very fun topic. So we're talking about OT, operational technology, and industrial control systems. There's a new room over at TryHackMe. And let me see if I can pull it up. That talks about industrial control system hacking. I think it's pretty interesting. We've done a couple of sessions in the past about this kind of stuff. Let's see. Industrial Control Systems, ICS. Looking forward to following the next material. Rex Silent, hello, nice to see you here. Hope you're having a good day. The world of OT ICS. So, I mean, I think we've covered ICS Modbus through this one, and attacking ICS Plant 1 and 2. But here's a new one over here. Introduction to the world of ICS. I had to learn more about OT. It's kind of neat. Yeah. I mean, it's always fun to learn about new technology. So that's one of the things we're going to be covering. Another thing we're going to be covering is more Active Directory hacking. So we're going to go back to Hack Smarter, and we're going to cover their Martini AD machine to do some more Windows Active Directory hacking. And we might use some of the techniques that we learned today when we do that hack. We're also going to be doing more digital forensics and more PCAP forensics. So everybody, come back next week and we'll be doing more hacking. It's more fun to watch without experiencing the frustration. I mean, whenever you do a challenge that you've never done before, there is the possibility that you might get stuck. So it's difficult. All right, so let's see who is on right now that we might want to raid into. So infosecstreams.com is a list of people who do cybersecurity streaming, so on YouTube or on Twitch. It doesn't look like there's anybody on right now. Hold on, let me see if there's somebody else on right now that we could raid into over on Twitch. And you know what? The great thing is that we didn't have any hiccups this stream. Hip Hop Hack, we didn't drop any frames. We didn't have any disconnections. Everything was good. Okay, so who's on right now? It looks like... Oh, Rob is on. But what is Rob doing? Oh, Rob is doing some IRL stuff. Let's see. Who else could we... I mean, we might raid into Rob because we don't have too many choices right now. Okay, let's see what he's up to. Okay, so when you arrive at the raided channel, if you could give this message right here, it's going to be OSFrog, Hip Hop Hack, OSFrog, like this. And it looks like Rob is eating some Chinese food. Oh, he's coming back. Okay, let's go ahead and start that raid. Raid RWX Rob. All right, everybody. Thank you very much for coming to today's stream. It's certainly been a very fun one, and I hope you have a great weekend. We'll be back on Wednesday. And all right, HackerFrogs out in 5, 4. Oh, before you go, if you want to join the Discord, it's over here, and the Reddit is over here. HackerFrogs out in 5, 4, 3, 2, 1. See you next time, everybody.